the first time that this is for the first time because the CBSE has introduced a new pattern of exams from this session, academic session 2021-22. Now, CBSE will hold 2 term-end examinations, one in November, December 2021, and the second in March, April 2022. Now, there are some very important instructions for all the teachers as well as the students. The first instruction is that in this term 1 examination, it will be a MCQ type of question, multiple choice type of question. And these questions will be in 2 ways. Either it is a case-based MCQ or an assertion or reasoning type of MCQ. Now the test will be of 1 hour and 30 minutes, covering 50% of the syllabi. Now the exam in these exams, the CBSE will send the questions to all the schools, and the examination will be conducted by the external superintendents and observers to be sent by the CBSE, and the MCQ type will be held in OMR sheet. Now, after the examination is conducted, these OMR sheets will be scanned by the respective schools and uploaded in the CBSE portal, or it may be evaluated and the marks obtained in this OMR exams will be uploaded by the school on the very day of examination. That is regarding term 1. Regarding term 2 examinations, as I told you, it will be held in March, April 2022, and it will cover. Now the examination will be of 2 hours duration, having 120 minutes, and these questions for term 2 examinations will be case-based or situation-based. It will be an open-ended examination, and in this examination, short questions or long type of questions will be asked. Suppose during the time of March, April, the situation is not conducive for holding the election in offline mode, then the situation, if it's not in the offline mode, then at that time, there is another alternative that in the second examination also, it will be an MCQ type of examination to be conducted. So in the second test, either long type, and if the situation is worse, then again, the alternative is MCQ type, basing on the rest 50% of the questions. And in both the term 1 and term 2, it will contribute to the final overhead score of the students. Now that is all regarding other parts that I will be telling you later. Now I welcome our Honorable Director, Professor Dr. A.B. Ota, the advisor, as well as the Director cum Special Secretary, to address you, the PGTs in physics. Dr. Ota, please.
Thank you, sir. Friends, this in our training program, why we have organized, normally we organize around, November, December, but this time the training program has been organized in the month of August itself for 2-3 reasons. I hope I am audible. Subhash sir.
Yes, audible. Audible, please. You are audible.
The COVID pandemic has grappled all of us. And because now the institutions have opened, we never know what is going to be the situation at any point of time. At any point of time, the wave may come in. It may not come, and our prayer to God has been that normalcy should be restored and normal classes will go on. However, keeping this possible unprecedented situation in view, ICSE, CBSE, even our state boards have also made certain changes in the examination pattern, in the course coverage pattern, pattern, everything has been changed. And this change is definitely new to you and also to the students who will be sitting in the examination. So we thought that with the most experienced hands in the state in all these subjects like physics, chemistry, botany, geology, and mathematics, as well as computer science and English, we'll be holding, close interactive classes with you, spanning from 9 to 1:15 p.m. every day. Probably this, each subject will take 3 days time, sir?
Yes, 4 days.
4 days
Each
time.
subject 4 days.
Okay, 4 days time, so that our experts who are part of the curriculum making will make you understand how it will come, how it should be prepared, how you should make your students prepared. This is very, very important. All of you know your subject matter, and all of you are, interacting with the children, transacting with the children so nicely in the classroom, for which good results are coming up, in EMRSs. However, you need to be abreast with the new system, and you should be told, you should be given tips by your experts as to how to prepare yourself and prepare your students, so that they will again come up successfully in the examinations. And the best part of this kind of a change is what government is trying to do, what boards have tried to do is, suppose, after 3 months time or 4 months time, another surge comes and the institutions are closed down. How this examination, marks will be used for deciding, divisions, percentage of marks. This is very important. Hence, you must also impress upon the students that they should be very careful in attending the classes and in attending the examination, which has been designed quite differently. I hope that this training program will be very useful, very handy for you in preparing, for classroom transaction, for covering the courses, orienting the children to get prepared for the examination. I wish that this, capacity building training program for the PGTs of EMRS will be extremely useful, and it will contribute to the, classroom transaction and achievement of the students. Thank you.
Thank you. Thank you, sir, for your kind words towards these PGTs, because I feel the PGTs should take more sincere effort to cope up with the new pattern of examination, and they should disseminate it among the students so that our students should secure more marks for this. Again, I am very much thankful to you, sir, for your kind words. And whether, I do not know whether, sir, whether Director ST will be joining?
I think, I only informed her today morning. She has not responded. In the course of the, since this is a 4-day training program, I'll rope her in one of these days. Okay?
Yes. Okay, thank you, sir. Now, on my left is Dr. Maheshwar Mahanti, the resource person of the first session. And he was my colleague at Government Autonomous College, Rourkela. And he's more or less a younger brother to me because he belongs to Puri town. And when I was studying in SS College Puri, he was also studying. He has retired as a very senior reader and very good teacher from Government Autonomous College, Rourkela. Now, I request him to start the proceedings within 2 to 3 minutes. Thank you, sir.
ଶୁଣନ୍ତୁ ସୁଭାଷ ସାର୍, ଆପଣ ଏଠି କଣ୍ଟିନ୍ୟୁ କରନ୍ତୁ till 11:45. 11:45 ପର୍ଯ୍ୟନ୍ତ ଆପଣ କରନ୍ତୁ. ମୁଁ 11:45 we have a meeting. I'll go
Yes,
for.
yes. Yes, yes.
Continue here, sir.
Yes, yes. That was also our plan.
Okay, okay, thank you.
এই বোর্ড কাই সনাতন কোন আপন ଦେଖିଆ ନଥିଲା।
Sir, this program which has been conducted by the SRT is a very useful program for the PGTs of EMS because of the present trend, the situation throughout the world is like this, so everything is being conducted in virtual mode. So this building training program for PGTs in physics, chemistry, botany, zoology, mathematics, computer science, and English will be of immense help to the PGTs. So regarding physics, is so far as the best subject of science, and the students, they take much interest in physics. At the same time, they have got some doubts in physics also. Doubts are not clarified, but by this method, the doubts will be clarified. The teachers will be very much trained. The teachers who are there to teach physics, by far, they are almost the best students of the institutions. So I hope all the teachers who are present in EMRS are very efficient to tackle the subject, and the present type of examination as derived by the government is mostly objective type, MCQ, multiple choice type questions. So to answer multiple choice type questions, it is very easy. At the same time, it's also very difficult. It is easy in the sense, if a student knows the answer, it takes no time for him to answer the question. But if he doesn't know it, then it becomes difficult. So for that, a thorough study is necessary. The students must have a thorough study of this, because this MCQ pattern of examination, which is based on the CBSE pattern. So all the teachers are requested to discuss the MCQs in class. Instead of giving the answer to the students, they must discuss it and find out how that answer comes. But the questions will come in form of MCQ in the first test. In the second test, as been proposed by the government, it may be long questions, short questions, and also MCQ. So more stress, always more stress will be there on MCQ, so that a student can answer MCQ if I studied it properly. So today we shall discuss about, in this session, we shall discuss about physics, that unit 3, chapter 5, which is magnetism. It's a very important chapter. Magnetism is a very important chapter. So far as short questions are concerned, there are few long questions from this chapter. Short questions are more important. The students will get almost 10 to 15% questions from this chapter. So this chapter is a very important chapter. So let us first know what is a magnet. When you are teaching magnetism to the students, it is obvious that a student will ask, what is a magnet? Which substance will be called a magnet? What is a magnet? The magnet which attracts the magnetic substances. What are the magnetic substances? Iron, cobalt, nickel, these are all magnetic substances. So these are attracted by the magnet. Whenever there is a magnet, it has got a field around it. The magnet has got a field around it. What is the meaning of magnetic field? Suppose we place a magnet here, a bar magnet, we place a bar magnet here. Bar magnet means a rectangular shape of magnet, type magnet. We place it here. It will attract the magnetic materials up to a certain distance, but it cannot attract all the magnetic materials placed anywhere. So the region in which it can attract the magnetic materials is its magnetic field. That is called a magnet. So every magnet has got its magnetic field. Strength of the magnetic field gradually decreases as we go away from the magnet. Magnet can be of different shapes. It can be magnet, can be a bar magnet. It can be a horseshoe magnet. It can be a cylindrical magnet. Like this, different types of magnets are there. With that, they have got two poles. Every magnet has got two poles, north pole and south pole. What is the meaning of a pole? What is the meaning of a pole? The student can ask this, though it is a very simple thing, but the students they might be getting down. What is the pole of the magnet? So, what is the meaning of the pole? The strength of the magnet is not same throughout. The strength of the magnet is concentrated at two points. Gradually, the strength decreases. In case of bar magnet, the strength of the magnet are toward the two sides, almost not exactly at the two sides, but almost at two sides. The points are called poles of the magnet, where the strength of the magnet is concentrated. The distance between two poles of the magnet is called magnetic length. Total length of the magnet is called geometric length. Geometric length is not equal to magnetic length. Magnetic length is less than geometric length, and almost magnetic length is almost 85% of geometric length. So we have got North Pole and South Pole. As the known that Coulomb's law of magnetism, like poles repel, unlike poles attract. And the repulsion is the sure test of magnetism. Whether it is a magnet or a magnetic substance, etc., the repulsion is the sure test of magnetism, not the attraction. Question may come in the examination, which is the sure test of magnetism? That is, answer is repulsion is the sure test of magnetism. So the strength of the force between two Coulomb's was there. The Coulomb's force of attraction and repulsion between two charges. There is also Coulomb's force of attraction and repulsion between two magnetic poles. The force is directly proportional to product of pole strength and inversely proportional to the square of the distance. More the distance, less will be the force of attraction. So, as you know, in that case, when the distance is increased, the force removes. So, what is the meaning of magnetic field intensity? Very simple. These are the fundamental things of magnetism. Magnetic field intensity. What is the meaning of magnetic field intensity? So, magnet is there. It has got its magnetic field. Then, what is this field intensity? Field intensity means strength of the magnet. Strength of the magnetic field at that point. What is the meaning of strength of the magnet at that point? The force with which unit north pole is attracted. For the force experienced by unit north pole at a point is called its magnetic field intensity. And so magnetic field is there, magnetic field intensity is there. Then, as we know, every magnet has got a north pole and a south pole. So a small magnet behaves like a magnetic dipole. Electric dipole is there, positive charge to equal positive charge and negative charge, they form an electric dipole. Similarly, two poles, north pole and south pole, separated by a small distance, they form a magnetic dipole. Magnetic dipole, then what is the dipole moment of the dipole? Dipole moment of the dipole will be equal to what? Pole strength into distance between the poles. Normally, we take pole strength at small m, and distance between the two poles is taken to 2m. So, pole strength of the magnet is equal to capital, denoted by capital M, that is equal to m into 2l. So, that is your magnetic dipole and its dipole moment. And dipole moment, since it is a moment, it is always a vector quantity. In the examination, question may come, dipole moment, whether it is a scalar quantity or vector quantity, dipole moment is always a vector quantity. If it is a vector, every vector has got a direction. If magnetic dipole moment is a vector quantity, then what is the direction? The direction is from south pole to north pole. In case of electric dipole, the direction of the dipole, electric dipole moment is from negative charge to positive charge. Here also it is from south pole to north pole, the vector quantity, dipole moment. So regarding intensity of magnetization, what is the meaning of intensity of magnetization? You magnetize a substance. Magnetize a substance is when you magnetize a magnetic substance. Suppose you magnetize iron. How far the substance has been magnetized? That is the intensity of magnetization. So every magnetic substance has got magnetic dipoles, but the dipoles are not properly oriented. They are randomly oriented. So dipole moment of one dipole cancels the dipole moment with the other magnetic dipole. Therefore, as a result, the piece of iron doesn't behave like a magnet. When you apply a magnetic field, what happens? The dipoles get properly oriented. When the dipoles get properly oriented, the dipole moment is set along a particular direction. One side of the substance develops north pole, the other side develops south pole. Then it becomes a magnet. That process is called magnetization. So when the process is magnetization, then what is the intensity of magnetization? How far the substance has been magnetized? That is the intensity of magnetization is what? Magnetic moment for unit volume. Magnetic moment, as I have already told, magnetic moment is equal to what? Pole strength into distance between the poles for unit volume will be called intensity of magnetization. That is called intensity of magnetization. Then what is the meaning of magnetic induction? These are the very important points in magnetic chapter. Magnetic induction. What is the magnetic induction? Normally we denote it by a symbol B. Magnetic induction at a place will be the field due to the magnetic induction. And your magnetizing field, you apply a magnetic field, substance becomes a magnet, and you get magnetic induction. Magnetic induction is B, magnetizing field is H. The relation between B and H is B is equal to mu into H. What is mu? Mu is the permeability of the medium in which the magnet is placed. Because that the medium plays a very important role. When a magnet is there, magnetic lines of forces will be there. It will affect the magnetic field, will be measured by the strength of the lines of force. So the magnetic permeability of the medium, how far the medium permits the lines of force to pass, that plays a very important role. So that is your magnetic permeability mu. It is normally usual symbol for magnetic permeability is mu. Similarly, another particular aspect of magnetic is there, that is susceptibility. What is the meaning of susceptibility? Susceptibility is equal to chi. Symbol, nor usual symbol for susceptibility is chi. That is equal to what? That is your intensity of magnetization for magnetizing field, I by H. Mu is equal to B by H. This is equal to I by S. Depending upon this value of mu and chi, the substances, magnetic substances are divided into three categories. What are the categories of magnetic substances? Diamagnetic substance, paramagnetic substance, ferromagnetic substance. Diamagnetic substance, paramagnetic substance, and ferromagnetic substance. From this chapter, the usual question may be a question: compare the properties between dia, para, and ferromagnetism. So there are 7 to 8 properties of diamagnetism, paramagnetism, or ferromagnetism. And ferromagnetic substances can be easily converted to magnets. But diamagnetic substance, they cannot be converted. Their susceptibility is negative susceptibility. Paramagnetic substance susceptibility is small susceptibility, and ferromagnetic susceptibility is more. Susceptible means, as the word indicates, how far the substance is susceptible to the magnetic field. So depending upon the value of susceptibility, the substance will be diamagnetic, paramagnetic, or ferromagnetic. When you heat a substance, suppose we heat iron, what will happen to its magnetic property? Or you heat a magnet, what will happen to its property? When you heat a substance, magnetic substance, its magnetic properties will be decreased. Why? What happens? So when you heat it, the dipoles which were aligned by magnetization now get de-aligned. Again, dipoles get de-aligned. De-aligned means they become randomly distributed. So magnetic properties decrease. So if you heat a ferromagnetic substance at a particular, the susceptibility gradually decreases. At a particular temperature, the diamond ferromagnetic substance becomes a paramagnetic substance. That temperature is called Curie temperature. So in the exam question comes, what is Curie temperature? Curie temperature is the temperature at which a ferromagnetic substance becomes paramagnetic substance. When what happens to the susceptibility of the paramagnetic with rise in temperature, when we change the temperature of paramagnetic substance, increase the temperature, its susceptibility decreases. So susceptibility of paramagnetic substance is inversely proportional to temperature. Chi is proportional to 1 by absolute temperature, chi is proportional to 1 by T. This is known as your Curie law. So other things are there, but to find out field intensity due to a bar magnet at the end on position, at a broadside end position. In blackboard is the blackboard is field intensity due to a bar magnet at end on position and broadside end position. You may get long question from this. End on position is not supposed to place a bar magnet. बोर्ड तो दरकार हो ना इससे तो बोर्ड दरकार हो मगर तो बोर्ड पर हां So long questions, there are almost from this unit, there are almost 3 long questions. One is to find out field intensity of the bar magnet at end on position, field intensity of the bar magnet at broadside end position, that is the equatorial position, and compare the properties of diaphragm and ferromagnet. These are the 3 long questions of the chapter, and rest will be short questions and objective MCQs. So, what is the meaning of end on position? Suppose a bar magnet is there. Bar magnet is there. Normally, the student will ask the question, what is the end on position? That is the point where the field intensity is to be measured is on the axis of the magnet. Is on the axis of the magnet. You will find out the field intensity here. That is at the end on position. There will be a deduction here. And the what is the broadside on position? Bar magnet is there. The point where the field intensity measured is in the perpendicular bisector of the magnet. This is called broadside position or equatorial position. So these are the 2 positions, long positions. By you can find out your field intensity. What is the meaning of field intensity? Force experienced by unit north pole placed at that point. in North Pole placed at this point will experience repulsive force to North Pole and attractive force to South Pole. So you find out what is the repulsive force to North Pole, attractive force to South Pole, and what is the resultant force. That resultant force is called field intensity at end on position or at an axial point. Question can be at an axial point or end on position. Same thing. Answer is same. Similarly, for broadside on position, you can find out force experienced by during North Pole pressure P, repulsive force to North Pole, attractive force to South Pole, and the resultant force can be found out by law of parallelogram of forces. The resultant force will be the field intensity. Field intensity at axial position is not same as the field intensity at broadside and position. That is find out taking the length of the magnet and the distance that can be calculated out. So regarding another important aspect of this chapter is terrestrial magnetism. Terrestrial magnetism means earth magnetism. As you know that earth is a magnet or earth is a huge magnet. Why do you call earth why do you say that earth is a magnet? How can you explain to a layman that earth is a magnet? Because if you place a needle magnet, the needle magnet will show a particular direction. Needle magnet will show a particular direction means it is definitely North Pole and South Pole of the needle magnet are getting affected by Earth. So Earth is a huge magnet. If Earth is a huge magnet, it must have North Pole and it must have South Pole. Then where is the North Pole of Earth? Magnetic North Pole of Earth, as you know, the North Pole and South Pole of Earth are geographic North Pole and South Pole. We are conversant with North Pole means geographic North Pole, South Pole means geographic South Pole. How the needle magnet is used to find the direction poles. When the needle magnet is suspended, the North Pole of the needle magnet remains toward the geographic north of Earth. The South Pole of the needle magnet remains toward geographic South Pole of Earth. So the North Pole of the needle magnet remains towards usually there's a doubt in many cases that the North Pole means that is the magnetic North Pole, but not that. When you suspend a needle magnet, the North Pole of the needle magnet remains towards geographic North Pole. What is the meaning of geographic North Pole of Earth? North Pole, which we call North Pole of Earth, we usually say that it is geographic North Pole. So, North Pole of the needle magnet remains towards geographic North Pole of Earth means the North Pole of Earth, geographic North Pole of Earth, has got south polarity. That's why North Pole is getting attracted toward that side. Similarly, South Pole of the needle magnet remains toward geographic south of Earth. Geographic south of Earth, since it's getting attracted to geographic south of Earth, definitely it has got magnetic north polarity. So remember it, geographic North Pole of Earth contains magnetic south polarity and geographic South Pole of Earth contains magnetic north polarity. So this usually is a doubt in case of many students, but to try to clarify it to the students that geographic North Pole contains magnetic south polarity and the geographic South Pole of Earth contains magnetic North Pole. Geographic North and South Pole, normally we call poles of Earth, geographic North and geographic South. So Earth is behaving as a, always behaves as a magnet. And the Earth magnetism, that is known as the terrestrial magnetism. It is characterized by three different factors. What are the three different factors? Three different factors are, one is your deep or declination. This is important. Deep or declination. Deep or declination. What is the meaning of deep or declination? What is the meaning of deep or declination? These are important things from examination point of view. The students have to be explained all these things so that they can remember. In the class, it should be explained to the students so that they won't have any doubt. What is the meaning of deep or declination? So magnet has got geographic north, Earth has got geographic north geographic south. Near geographic north, there is a magnetic south. Near geographic south, there is a magnetic north. So the two axes containing geographic axis and magnetic axis of Earth are not coincident. Remember, geographic north pole is not coincident with the magnetic south pole of Earth. So the geographic axis and magnetic axis of Earth are not coincident to different axes. So vertical plane passing through the geographic axis and the vertical plane passing through the magnetic axis are inclined. There is some angle between them. Those planes are called meridian. The plane passing through a vertical plane passing through the magnetic meridian, geographic axis of Earth is called geographic meridian. Not that there is a plane, just imagine imaginary vertical plane. The imaginary vertical plane passing through geographic north-south of Earth, that is geographic axis, is called geographic meridian. The imaginary vertical plane passing through magnetic north-south of Earth is called magnetic meridian. The angle with both are not considered, they are inclined to each other. The angle between the two planes, the geographic meridian and magnetic meridian, is called deep or declination. That is the definition of deep or declination. Deep or declination at a place is defined as the angle between magnetic meridian and geographic meridian of Earth. Second one, which is also very important. Angle between, next is angle between you see the arc field. Arc field can be divided, can be divided into components. Component along vertical direction and component along horizontal direction. Arc field can be the angle between the resultant magnetic field and the horizontal component, that is called deep angle. Angle between that the declination or variation, it is called deep or inclination. Second one is deep or inclination. Deep or inclination. Yes. Variation or declination, that is the angle between magnetic meridian and geographic meridian. Deep or inclination is the angle between the horizontal component of Earth magnetic field and the resultant intensity. That is called deep. Our third parameter of Earth magnetism that is the horizontal intensity. Horizontal intensity. So there are three characteristics of Earth magnetism. In the examination, students may get short question. What are the characteristics of Earth magnetism or a terrestrial magnetism? The terrestrial magnetism is characterized by three important factors. What are the three important factors? The first factor is declination or variation. What is the meaning of declination or variation? Declination or variation means the angle between magnetic meridian and geographic meridian. I have already told you what is the meaning of geographic meridian, what is the meaning of magnetic meridian. The geographic meridian is the imaginary vertical plane passing through the geographic axis of Earth. Magnetic meridian is the imaginary vertical plane passing through the magnetic axis of Earth. Both the planes are not considered, they are inclined. The angle of inclination is called variation or declination, which vary from place to place on the surface of Earth. Second characteristic is deeper inclination. What is the meaning of deeper inclination? It is the angle between the horizontal intensity and the resultant intensity of Earth magnetism. Because the Earth magnetism can be resolved into components along a horizontal direction and along a vertical direction. The angle between the horizontal component and resultant magnetic field is called deeper inclination. It also changes from place to place. It is maximum or deep, it is maximum at the poles. It is 90 degrees. Very often the question comes, where deep is maximum, or what is the deep value of deep at the equator? What is the value of deep at the poles? Value of deep at the poles is 90 degree. Value of deep at the equator is 0 degree. And the third parameter is horizontal intensity. That is your component of our magnetic field in horizontal direction. So, if vertical component is V, horizontal component is X, resultant intensity I, and there is a relation between them. I square is equal to what? V square plus square. Or I is equal to V square plus S square. So, these are the characteristics of Earth magnetic. So, these are to some extent something about this, and in addition to that, your revolving electron behaves like a magnetic dipole. How does a revolving electron behave like a magnetic dipole? Is very important. When an electron is revolving in hydrogen atom, it behaves like a magnetic dipole. How? How the magnetic dipole means it must have a magnetic moment. Then let us find out how it behaves as a magnetic dipole and what is its magnetic moment. Now, what is the magnetic moment? When an electron is revolving, orbital magnetic moment of revolving electron. Orbital magnetic moment of revolving electron. When an electron is revolving, it behaves like a magnet. So it has got magnetic moment. Then how to find out? So magnetic moment is usually given by the I into A. I is the current and A is the area of the loop. So let us find out when the electron is revolving. Revolving means a charge is moving, and you know that when a charge is moving, it is associated with a current. Current means a charge is moving, that must be a current. So when an electron is revolving, what is the rate of flow of charge? The rate of flow of charge will be current. So rate of flow of charge, how to find out the current? I is equal to charge by time period. Charge by time period. Rate of flow of charge. What is charge of electron? Charge of electron is E. What is the time period? How much time it takes? Suppose the radius of the orbit is R, velocity of electron is V. So what is the time period? Time period will be what? 2 pi R by V. R is the radius of the orbit. So distance covered in one revolution is 2 pi R. V is the velocity. So time period will be 2 pi R by V. R is what? Radius of the orbit. R is the radius of the orbit. V is velocity of revolution. Velocity of revolution. Velocity of revolution. So your I becomes what? Current becomes what? E into V. Charge. E charge of electron. 2 pi R. This is your current. Electron is moving means this is the current. I is equal to EV by 2 pi R. EV by 2 pi R. What is the area of the loop? R is the radius of the orbit. So area of the loop is current loop is what? Area of the loop. These are very important. The students have to understand all these things. Area of the loop is pi R square. Then how much is orbital magnetic moment? Orbital magnetic moment orbital magnetic moment is equal to how much? I into A. Orbital magnetic moment is I into A. I into A is symbol is what? We will orbital magnetic moment. We will I into A. So let us put the value. What is the I? I is equal to what? EV by 2 pi r into area is equal to what? Pi r square. So this is equal to what? EVR by 2. So orbital magnetic moment is EVR by 2. The students should be instructed to remember the value. At the same time, they should understand how this orbital magnetic moment becomes EVR by 2. When an electron is revolving in an orbit, how it behaves like a magnet, and the magnetic moment associated with it is EVR by 2. V is the velocity of revolution and R is the radius of the orbit. Next is your current loop. A current loop is a circular loop of current is there. Means current is flowing in a circular loop. It behaves like a magnetic dipole. Current loop as a magnetic dipole. Current loop as a magnetic dipole. Current loop as a magnetic dipole. Current loop means that is a circular current. A current carrying loop behaves like a magnetic dipole. A current carrying loop behaves like a magnetic dipole. This is important. A current carrying loop behaves like a magnetic dipole. How it behaves like a magnetic dipole? What is the when the current carrying loop is there, circular loop is there? What is the magnetic flux density? The magnetic flux density formula is what? B, magnetic flux density. Magnetic flux density. What is the value of magnetic flux density? Mu 0 I A square by 2r cube. Mu 0 I A square by 2r cube. That can be written as mu 0 by 4 pi, constant factor. Mu 0 is 4 pi into IA by r. So magnetic flux density mu 0 is 4 pi 2 IA by r. Similarly, electric field due to the electric dipole, electric field due to an electric dipole. Electric field due to an electric dipole is given by what? E is equal to how much? 1 by 4 pi epsilon 0, 2p by r cube. 2p by r cube. P is the dipole moment of the electric dipole. So you see, look at both the expressions. B is equal to what? Mu 0 by 4 pi 2ia by r cube. Electric field due to electric dipole is equal to 1 by 4 pi epsilon 0 2 pi r cube. So in both the cases, both B and E are proportional to what? Proportional to 1 by r cube. So circular current loop is behaving like a magnetic dipole, and dipole moment associated with it is how much? What is the dipole moment associated with it? Dipole moment associated with it is how much? dipole moment associated with the circular loop. Dipole moment is equal to how much? I into A. What is dipole moment associated with it? I into A. A circular loop carrying current, remember it. A circular loop carrying current behaves like a magnetic dipole, and the dipole moment associated with magnetic dipole is given by I into A. What is I? Current flowing to the coil. What is A? Area of the coil. Loop area. Suppose the loop is carrying number of turns. This is for one turn. Suppose the loop is carrying number of turns. If number of turns in case of n turns, suppose n turns are there. In case of n turns, the dipole moment is dipole moment Ni, dipole moment is how much? Ni. Number, if the number of turns are n, then it is Ni. A dipole moment is Ni. So these are the subjective type matter from this magnet. What is a magnet? What is magnetic field? What is field intensity? What is intensity of magnetization? What is magnetic permeability? Magnetic susceptibility? How does magnetic susceptibility change the temperature? What is paramagnetism? What is diamagnetism? What is ferromagnetism? And what is Curie law? What is Curie temperature? These are important things. What is Curie law? In the examination question of state Curie law. What is Curie law? What is Curie temperature? What is D? What is declination? What is horizontal intensity? What is the value of D for the pole? What is the value of D for the equator? Then where dP is maximum, where dP is minimum, then electron revolving around the nucleus is behaving like a magnetic dipole, and a circular current loop is also behaving like a magnetic dipole, and dipole moment associated, remember, dipole moment associated with it is given by I into A. I is the current, A is the area. If the number of turns, there are number of turns in the loop, n turns are there, then total dipole moment will be how much? Ni. So basing on this, we can have number of MCQ, multiple choice questions. Now more stress is given on multiple choice questions because total 50% of the questions will be multiple choice type. So students should be able to answer the multiple choice questions. Multiple choice questions are very easy. At the same time, they are also very difficult. Very easy in the sense, the student knows the answer, he can answer it in very short time. But if he doesn't know the answer, it will take a long time and cannot get the answer also. So there must be in the class multiple choice questions from each chapter, and from every chapter also, while teaching different chapters, should be vividly discussed. What are the various types of multiple choice questions? If a student reads this chapter thoroughly, all the multiple choice questions will be in that. The answers of the questions will be inside them. Suppose there is a multiple choice question. When the distance in two magnetic poles is doubled, the force between the poles becomes double, becomes half, becomes 4 times, decreases to 1/4. What happens here? When the distance between two magnetic poles is doubled, so what is the force between two magnetic poles? F is equal to how much? Mu0 by 4 pi m1 m2 by d square. This is the force of attraction repulsion between two poles. Mu0 by mu0 is the permeability of free space. M1 m2 pole strength. D is the distance. The question is, when the distance between two magnetic poles is doubled, distance is doubled, D is doubled. D is doubled means what will happen to the force? When D is doubled, force will be how much? Force will be 1/4. So the choice, number of 4 choices will be there. One will become double, becomes half, becomes 4 times, decreases to 1/4. If the student knows the formula, he can answer the question. If he doesn't know the formula, he will just give a tick anywhere. But the correct answer is it becomes what? Becomes 1/4. Similarly, what is the value of permeability? Permeability of air of free space. Normally we take air as a free space. What is the value of permeability in air? 10 to the minus 7 Newton per meter ampere square. 4 pi 10 to the minus 9 Newton into ampere square. 4 pi 10 to the minus 7 Newton by ampere square. 10 to the minus 9 Newton ampere minus 2. So what is the correct value of this value to be remembered by this student? Which is the correct value? Correct value is the value of usually 4 pi 10 to the minus 7 Newton per 10 to the power minus 2. Next, iron is used as a core in a transformer because why do we use in a transformer? No, the transformer is the electric chapter. Inside the transformer, in the core of the transformer, we have got soft iron. Why do we use it? The choice of number of choices are there. Number 1, it is strong enough. Number 2, it has high density. Number 3, it has high permeability. Number 4, none of these. So which is the correct answer or which iron is used in a transformer? The correct answer is first, it is not correct answer. It is not strong enough. It is high density, not that. It has got high permeability. Since iron has got high permeability, it is used in the core of a transformer. Next is, as we are discussing about the susceptibility, for a diamond substance, choices are there. Chi is positive, chi is negative, chi is 0, chi is equal to concept of two different apparent into different ways. Yes, we'll discuss it later. It's all right. For a diamond substance, chi is positive, chi is negative, chi is equal to 0, and chi is equal to 1. For a diamond substance, what is the value of chi? Chi is negative. Chi is magnetic susceptibility. Another short question is there. The sure test of magnetism is attraction, repulsion, both of these, none of these. Which is the sure test of magnetism? Sure test of magnetism is repulsion, never attraction. In repulsion is sure test of magnetism. The unit of force strength is Henry. The unit of force strength twice is given. Henry. Next is Tesla. Next is ampere meter. Next is Weber. All these things are there. Henry. Henry is the unit of what? Inductance. Inductance. Tesla is the unit of what? Magnetic induction. Weber is the unit of what? Magnetic flux. So what is the unit of force strength? Force strength unit of force strength is ampere meter. Force strength unit of force strength is ampere. And questions, MCQs can be of this like this. Now, what is the dimension of force? Dimension of force strength. Dimension of force strength. Dimension of force strength. Dimension of unit of force strength is ampere into meter. So dimension of force strength, out of this, which will be dimension of force strength? You see, choices are there. First, very simple question. M to the power 0, L to the power 0, T to the power 1, A to the power 1. B, M to the power 0, N to the power 1, T to the power minus 1, A to the power 0. Number C, M to the power 0, N to the power 1, T to the power 0, A to the power 1. D, M to the power 1, L to the power -1, T to the power 0. So while choosing the dimension, how to find out the dimension, what is to be done? As I see, what is the unit of this pole strength? Unit of pole strength is what? Ampere into meter. Ampere into meter. So you student need not remember what is the dimension of pole strength. If you remember, then you will commit mistake in the examination. So ampere meter means what? Ampere dimension A, meter dimension is what? A is that is A to the power 1, L to the power 1. So definitely, which is the correct answer? M to the power 0, L to the power 1, T to the power 0, A to the power 1. The next question is Curie point. I have already discussed about the Curie point. What is Curie point? Curie point is the temperature at which a ferromagnetic substance becomes a paramagnetic substance. When a paramagnetic substance is heated, its magnetic property decreases. At a particular temperature, a ferromagnetic substance becomes paramagnetic. So the question is like this: above Curie point, a ferromagnetic substance becomes diamagnetic, paramagnetic, ferromagnetic, non-magnetic. So definitely the answer will be what? Paramagnetic. Above Curie point, ferromagnetic substance becomes paramagnetic. Next, the angle of D is maximum near equator at 45-degree latitude. Pole, none of the above. While discussing, I have already discussed about the deep. Deep is maximum at the what? At the poles. So at the poles, value of deep is 90 degrees. A diamagnetic material in a magnetic field moves perpendicular to the magnetic field from weaker part to the stronger part, from stronger part to the weaker part in none of the above direction. So a diamagnetic substance is kept in a magnetic field. It moves. The question is, it moves. How it moves? Number one, perpendicular to magnetic field from weaker part to the stronger part, from stronger part to the weaker part, in none of the above directions. So what will answer? A paramagnetic diamagnetic substance gets repelled in a magnetic field. Diamagnetic substance gets repelled in a magnetic field. So a diamagnetic substance is getting repelled means it will move from which part to which part? From stronger part to weaker part of the magnetic field. And the question is, another question is there. The MCQs, there may be problems in the MCQs. MCQs may be in form of problems also. The question is, a magnet with magnetic moment is given, it is bent into a semicircular form. Its new magnetic moment will be. A very important question. The students should know how to answer this. Magnetic moment is M. Magnetic moment is capital A. It is this magnet is bent into a semicircular form. The magnet is bent into a semicircular form. Semicircular form, like this, semicircular form. Bent to a semicircular form. Its new magnetic moment. What will be new magnetic moment? Whether the new magnetic moment remains same or it is different. How to find out the new magnetic moment in this case? For circular route, magnetic moment is how much? Magnetic moment has already known pole strength into what? Pole strength into 12. M into 12. So what is your force strength? Force strength is what? M by 12. M is magnetic moment and 12 is the distance. In this case, what is the radius? The 2L is converted to a semicircle. This is the total length is 12. In this case, 2L is equal to what? 2L is equal to pi r. 2L is equal to pi r. So what is r? R is equal to how much? 2L by pi. R is equal to 2L by pi. So this, what is the distance between these poles now? That question. ಈ question ଟା ଏଠି କହିଦେବି ଏଇଟା ଛାଡିଦେବି r is equal to 12 by pi. Now what is the distance between the two poles? Here is one pole, another pole is here. What is the distance? You can see 2r. This distance is 2r. So what is the new magnetic moment? New magnetic moment is what? New magnetic moment is equal to m dash of volts, small m into 2r distance, small 2r. Because the pole strength remains same, small m into 2r. That is equal to small m into 2r. In place of 2r, we have got for r equal to 12 by pi. So 2r is 4l by pi. 4l by pi. So this is equal to what? 2ml into 2 by pi. That is equal to what? 2m by pi. So new magnetic moment becomes 2m by pi. So if you take a magnetic moment m and bend it into the semicircular form, in that case, new magnetic moment is 2m by pi. So the question that we discuss the concept of true deep and apparent deep in two different ways. What is the meaning of deep? Deep is the angle between what? Result and the form and the horizontal component. So true deep is if you exactly find out the component, the horizontal component, the angle between the resultant and the horizontal component is deep. But if exactly not find out the axis, in that case, you don't get the exact value of deep, so it becomes what? Apparent deep. So, but the exact value of exact deep, true deep, and the force in 90 degree and that actuator at each 0 degree. Apparent deep will be something different from that, but the value will change between 0 degree and 90 degree. And the poles in 90 degree and the equator it is 0 degree, which is the most important characteristics of earth magnetism. Thank you.
And now we will join after 5 minutes. Please wait for 5 minutes. We are shifting to another room because there is one urgent meeting here. So we are shifting to another room. So all of you are requested to be online and we will join again after 5 minutes. ମ୍ୟାଡ଼ାମ ଆସିଲେ ଜଏନ୍ କଲେ କି? Masal Salaki. Dear friends, now we are going to start the second session, and I welcome Dr. Mahanti to start his deliveries.
Now, the second session will be based on this ray optics. In optics, so we have ray optics and wave optics. In this session, we shall discuss about ray optics. In ray optics, the syllabi for the ray optics starts with the refraction of light, lens, different optical instruments, etc. The reflection portion are almost removed from the syllabus. So, starting from refraction, that is your total internal reflection, etc., critical angle, will go to the lens makers for lens, converging lens, diverging lens, lens combination, power of a lens, different optical instruments, simple microscope, compound microscope, astronomical telescope, optical fiber, etc. And basing on those things, we'll discuss the MCQs, which can be asked from this end. Also, lens makers formula, numericals can be asked as MCQ, basing on the power of the lens maker formula, relation to object distance, image, etc. So many things are there. So, starting with that, we'll first discuss about total internal critical angle and total internal reflection. What is the meaning of critical angle and total internal reflection? Reflection and total internal reflection. What is the difference between the two? The students know that because there is no reflection. Now, what is this? How does this word total internal reflection comes? When light falls on a surface, a part of light gets reflected, a part gets absorbed, a part gets transmitted. Three different phenomena will occur. When light is incident on a surface, there are three different phenomena. A part will be absorbed, a part will be reflected, a part will be transmitted. How much percentage of light will be reflected, how much will be absorbed, how much will be transmitted, depends upon the nature of the surface on which light is incident. When it is incident in a plane mirror, more amount of light will be reflected. If it is incident in a glass slab, more amount of light will be transmitted or refracted. Then what is the meaning of total internal reflection? Total internal reflection means when light is incident in such a manner that total amount of light is reflected back. No percent of light is absorbed or no percent of light is refracted. 100% of light gets reflected back to the first medium again. So that is the total internal reflection. Total internal. So what are the conditions for in the examination? Short question come. What are the conditions for total internal reflection? What is total internal reflection? What are the conditions necessary for total internal reflection? Everywhere total internal reflection cannot take place. There are certain conditions for total internal reflection. What are the conditions? First condition is that light must travel from denser medium to a rarer medium. That is the first thing, first characteristic, first requirement. Light must go from denser medium to a rarer medium. Second characteristic, that angle of incidence must be greater than critical angle for that pair of media. These two conditions must be maintained for total internal reflection. Otherwise, there cannot be any total internal reflection. So what happens? You see, that light travels from what? Travels from denser medium to rarer medium. Total internal reflection, first condition is light travels from denser medium to rarer medium. This is a denser medium. A rarer medium. You can take glass air, denser medium glass, rarer medium air. What air, water, like that. So when light is into a denser medium, the normal at the point of incidence, and as you know, the angle of refraction becomes more than the angle of incidence. It depends on normal. When it moves from a rarer medium to denser medium, it depends toward the normal. When it moves from denser medium to rarer medium, it depends away from the normal. This effect of light is called refraction of light. So here refraction takes place. Angle of refraction is, this is your angle of incidence. The angle of refraction, angle between the incident and normal, angle between the refracted and normal. So angle of refraction is more than what? More than the angle of incidence. Now you increase the angle of, let us increase the angle of incidence. I will increase the angle of incidence like this. When I increase the angle of incidence, in which direction the angle of refraction will go? The angle of the refracted ray will travel like this. Again, towards that. At a particular angle of incidence, the refracted ray will travel over the surface of separation. So in this case, at this particular angle of incidence, we won't increase the angle of incidence, stay this term, when the angle of refracted ray will travel over the surface of separation. That is told that the refracted ray grazes the surface of separation. So what is the angle of refraction in this case? In this case, angle of refraction becomes what? 90 degree. So the angle of incidence for which the angle of refraction becomes 90 degree is called critical angle for that pair of media. Very important. So which angle is the angle of incidence? Critical angle. This angle is not a critical angle. This angle is critical angle. This angle is called critical angle. The angle of incidence for which angle of refraction is 90 degree. When the ray is traveling from denser medium to rarer medium, is called critical angle for that pair of media. If you change the medium, then the value of critical angle will change. So critical definition of critical angle is very important. Students should remember the definition because it is very important. So critical angle is defined as angle of incidence, that particular angle of incidence for which the refracted ray grazes the surface of separation or angle of refraction becomes equal to 90 degree. So that is denoted by some books in C or in some books it's simply C. Critical angle. So what is the relationship between that refracted? Because you know that refracted Snell's law, sin R mu is equal to sin R by sin R. Sin of the angle of incidence gives a constant ratio with the sin of the angle of refraction for the same pair of media and for the same color of light used. This is called Snell's law. So in this case, the value of mu becomes what? E is equal to 1 by what? Sin C, or you can also write sin I C. P is equal to 1 by sin C. So this is the concept of a critical angle. So for critical angle, to get critical angle, light must travel from denser medium to rarer medium. Second, now let us increase the angle of incidence further. Now let us increase the angle of incidence further. Further means beyond the critical angle. If the angle of incidence is increased beyond the critical angle, what will happen? Light has no scope to come to this side. It will go where? It will be reflected back to the first medium. Light is moved. Light will be reflected. If we increase the angle of incidence, that will be reflected. This reflection is called total internal reflection. This is called total internal reflection. So when total internal reflection takes place, if the angle of incidence is more than the critical angle. So two important conditions are there for total internal reflection to take place, that light must travel from denser medium to a rarer medium. Second, angle of incidence must be greater than the critical angle for that pair of media. On this, there can be some questions, there can be objective questions also, and numericals, which can also come as MCQ. The students are advised to remember the formula, V is equal to 1 by sin C, where C is the critical angle and V is the refractive index. What is the meaning of refractive index of the medium? What is the meaning of refractive, absolute refractive index and relative refractive index? Absolute refractive index is relative refractive index. What is the difference between the two? Suppose you say that refractiveness of glass, that means we say absolute refractive index of glass. Absolute refractive index mu, suppose you say that mu G to glass. That is the absolute refractive index of glass. Absolute refractive index of medium is C by what? Vg. C by Vg. What is C by Vg? C is velocity of light in vacuum, Vg is velocity of glass. That is mu G equal to C by, that is absolute. So in general, what is absolute refractive index of medium, mu is equal to what? C by V. This is important formula. mu is equal to C by V. In general, mu is equal to C by V means C is velocity of light in vacuum. That is a constant value. That is 3 × 10⁸ meters per second. Everybody knows that. The students are right to remember that. In the question, value of C may not be given. In numericals, where value of C is not given, the students have to remember this important value. C is equal to what? 3 × 10⁸ meters per second. And V is velocity of light in the medium. That is your refractive. But what is the meaning of relative refractive index? Relative refractive index means what? If suppose light is traveling from air to glass, light is traveling from water to glass, light is traveling from one medium to another medium. So in that case, what? What is relative refractive index? Relative refractive index, suppose A mu G. What is the meaning of A mu G? What is the meaning of A mu G? A mu G means what? Refractive index of glass with respect to air. That means light is traveling from air to glass or from glass air to. So in that case, how to find what is this value? This value is what? VA by VG. VA by VG. What is the VA by VG? VA is velocity of light in air divided by velocity of light in glass. Normally, in case of the air, we normally take velocity of light with 3 × 10⁸ meters per second. The convention. Suppose you write W mu G. What is the meaning of W mu G? What is W mu G? Refractive index of glass with respect to water. So that is equal to what? That becomes equal to velocity of light in divided by velocity of light in glass. Yes. So this is how you find out the refractive index of one medium with respect to another medium. The refraction also takes place in case of a prism. Suppose you take a prism. In case of a prism, refraction takes place. If incident white light on a prism, you get how many colors will be present? On the after refraction, there will be 7 colors, and the colors are like this. Violet, indigo, blue, green, yellow, orange, red. Violet. So, like this. White light is incident here. This is your red color. This is your in between all other colors will be there. So white light, which is a polychromatic light, it is not a monochromatic light. What is the meaning of a monochromatic light? Light which consists of a single color, that is called a monochromatic light. Polychromatic light is a combination which contains number of colors. White light is a polychromatic light which contains 7 colors. 7 colors are there. Blue spectrum, that is your red to violet. So from this, when it is incident in white light, incident in a prism. So it gets splitting takes place from this. The refraction takes place here. So it gets divided into red color and violet color. In between all other colors will be there. Similarly, again refraction takes place here. It gets divided into this. All other colors remain in between R and V. So which color is maximum deviated? Which color is minimum deviated? Maximum deviated color is violet color. Minimum deviated color is red color. So red and violet are called extreme colors. This phenomenon of separation of white light into its constituent colors. Constituent colors means white light is constituted of 7 colors. Constituent colors are if they are violet, indigo, blue, green, yellow, orange, red. So this phenomenon is called what? Dispersion. Dispersion. Who is dispersing? The prism is dispersed. Prism is dispersed. Dispersed. And you are getting a 7 patch of 7 colors on the screen. This patch is called a spectrum. Spectrum. The splitting of white light into the constituent color is called dispersion, and the colored patch obtained on the screen is called dispersion. Is called a spectrum. The instrument by which you can study a spectrum is called a spectrometer. By a spectrometer, you can study a spectrum. The color which undergoes in between mean deviation, red color and violet color, extreme colors, then the least deviated, the maximum deviated, yellow color is minimum deviated. So yellow color is called the mean color. Yellow color is called the mean color. Mean color is the spectrum. And this entire thing, branch of physics, which deals with study of all these phenomena, is called spectroscopy. Spectroscope. How to find out that? And the question is, who is producing the colors? Whether the prism is producing colors, or question comes in examination. The prism is producing the colors, or colors are already present in white light, and in the prism we separate the colors. The answer is the coloration is not produced by the prism. Colors are already present in white light. It is the prism which separates the colors. Why does the prism separate the colors? What happens when the prism is separating the color? The prism is separating colors because when the white light is incident, different colors undergo different deviation. Different colors get undergo different deviation, and the colors are separated. From those colors, red undergoes minimum deviation, and violet undergoes maximum deviation, and all other colors undergo deviation present in between. Therefore, we get so prism doesn't produce coloration. Prism only separate the color which are already present in white light. And we take the program on this. Now, question program is equal to sin A plus B by 2 by sin A by 2. It is a very important question. In the exam, this may come as a long question. Sin B is equal to sin A plus B by 2 by sin A by 2. What is A? A is angle of the prism. DM is what? Angle of minimum deviation. And angle of minimum deviation means what? What is the meaning of angle of minimum deviation? You change the angle of incidence, the angle of deviation will change. When the angle of incidence is increased, angle of deviation goes decreases and then increases. If you plot a graph like this, the practical students will do this. I versus D for I versus D. So what happens when we record V of this like this? U shaped curve. Inverted U shaped curve. When angle of incidence increase, angle of deviation decreases. But it doesn't decrease indefinitely. It increases up to a certain limit. So here up to this it decreases. Then if you increase angle of incidence further, angle of deviation and again increases. So this minimum value, this deviation is called angle of minimum deviation, and it is very dm. So if the angle of minimum deviation is dm, is the refractive index of the metal is given by mu is equal to what? Sin A plus B by 2 by sin A. When the angle of deviation there is minimum deviated, in that case what happens? I becomes equal to I dash, R becomes equal to R. I dash means what? Angle of incidence and angle of emergence. There are two refractions. Refraction in the first place, refraction in the second place. So refraction in the first place and refraction in the second place, so I dash, R dash. So when the ray undergoes minimum deviation, angle of incidence becomes equal to angle of emergence, and angle of R becomes equal to R dash. So let me comment this formula. Either sin A plus B by 2 is. In lens, there are different types of lens, mostly convex lens, biconvex lens, and biconcave lens. Biconvex and biconcave. Both sides concave, both sides concave. And in between, there will be different types, plano-convex, plano-concave, convex, concave or convex, or convex or concave. So many types of lenses are there, like this. So, and lens, there are a number of terms to be defined in case of lens, and I have explained to the students. And the lens formula 1 by V minus 1 by U is equal to 1 by F. Important lens equation. Relation of object distance, image distance, and focal length of frames. So 1 by V for a convex lens, produces real image, virtual image, for a concave lens, producing virtual image like this. And most importantly, it's lens Becker's formula. What is lens Becker's formula? 1 by F is equal to what? This formula is very important to students. The deduction formula may not be that important, but the students should understand the formula and do numericals on that. So 1 by F is equal to what? U2 by mu1 minus 1 in 1 by R1. This is equal to lens because what are these mu2 mu1 inside to excess, or in place of mu2 by mu1, then take mu minus 1, 1 by R1 minus 1 by R2, R1 radius of curvature of one surface, R2 radius of curvature of the other surface, another surface. So this formula is very important. F is equal to yes. Basing on this formula, we'll discuss some questions also. How the problems can be solved on this, basing on this problem. Then important is power of a lens, because multiple choice questions will come from these things. Power of a lens. What is the meaning of power of a lens? Power of a lens is given by what? D. Power of a lens is equal to what? 1 by F. Power of a lens is equal to what? D. You can take D, or you can take E also. Power of a lens is equal to 1 by F. Reciprocal of focal length, when important, when focal length is expressed in meters. So that is to be explained to the students. The students should remember that power of a lens is defined as the reciprocal of focal length. When focal length is expressed in meters. Suppose you are provided with a lens of focal length 40 centimeter or 20 centimeter, for example, 20 centimeter. 20 centimeter. Question will be, what is the power of a lens? Power of a lens is equal to what? P is equal to not 1 by 20. You don't do so simply know that is reciprocal of focal length. You write 1 by 20, it's not 1 by 20. F was to express in meters. So this becomes what? 1 by f focal length extended meters 20 by 100. So this is not but 5. I got and that 2 and that power of length 5. So you can also remember like this P is equal to what? 100 by f. You can also remember that. In that case, you write 100 by f. In f, you can write in centimeter. Or always remember, focal length is to express in weight. So a question can come, focal length is given, calculate power. Power is given, calculate focal length. Question, multiple choice questions can be this type. Lens combination, suppose you are combining two lenses. Then what is the combined power? Combined focal length. The formula goes, remember 1 by f is equal to 1 by f1 plus 1 by f. Two lenses in contact. When you are separating, two lenses are separated, the formula becomes 1 by f equal to 1 by f1, 1 by f2, plus a by f1, f2. That is not required, very much required for the first level. But remember this 1 by f is 1 by f1 plus 1 by f2. So power is equal to what? P is equal to what? P1 plus P1. This is our power of a lens combination. Numericals in MCQ, civil MCQ will not be only the numericals will be there. Numericals can form in place of in set of MCQs also. So if the students know the formula and can answer the MCQs. Regarding optical instruments, we have got a simple microscope, compound microscope, astronomical telescope. In a simple microscope, just a convex lens, or it is called a reading glass. Simple microscope is a reading glass, and it's a convex lens. So, what is this magnification? This magnification for N is equal to 1 plus 1 d by f. 1 plus d by f. Magnification formula is 1 plus d by f. What is 1 plus d by f? D is what? Least distance of distribution. What is the meaning of least distance of distribution? If you see something, suppose you place this object at a larger distance, you cannot see it very distinctly. You place the object very close to your eye, you can also cannot see it distinctly. At a particular distance, it will be clearly seen. So that particular distance is called least distance distribution, which is equal to how much? For a normal eye, D is equal to what? 25 centimeters. Least distance of distribution. If you place the object within 25 centimeters from the normal eye, you cannot see it distinctly. So least, so formula is that this formula is divided. In this case, in the simple microscope, it's just a convex lens, or it is also called a reading glass or a magnifying glass. So, to get more magnification, to see very teeny objects, we do not use a simple microscope, we use a lens combination. Two lenses will be taken. So, that lens combination is called a compound microscope, which contains two lenses, two convex lenses. In that case, one is called objective, which is placed near the object. The other is called eyepiece, which is placed near the eye. Clear? So, two lenses are so that definitely your magnification in that case will be more. And magnification in that case becomes what? F4 by F3, or like F4 by F3, 1 plus T by F3. This is the magnification case of compound microscope. What is F4? Focal length is the objective. What is the objective? Which is lens, which is toward the object. What is the eyepiece? Lens, which is toward the eye, near the eye. And D is the least distance. These things are there. So in this case, magnification is very much increased. Magnification very much increased. The compound microscope. So these are the objects. You can say another optical instrument is there. Astronomical telescope. Then the test you can see So heavenly bodies, astronomical telescope, that is also a lens combination. So in that case, magnification becomes what? F4 by F4 focal length of objective, focal length of the so they your astronomical telescope. So now we'll discuss some short questions based on this chapter. Some of the question is focal length of the lens of power 5 diopter is 25 centimeter, 10 centimeter, 2.5 centimeter, 20 centimeter. I have already told you they may give you focal length and ask for power. They may give you power and ask for focal length. Here the power is given and focal length is asked. What are the choices? 25 centimeter, 10 centimeter, 2.5 centimeter, 20 centimeter. The focal length power is 5 diopter. When the power is 5 diopter, you know the formula, power is equal to P is equal to what? 1 plus 1 by F. F is expressed in what? Meters. F is expressed in meter. Power is 5. So focal length is how much? F is equal to 1 by P. 1 by 5. 1 by 5 meter. That is equal to how many centimeter? 20. So focal length of the lens is 20 centimeter. The student, so when you are teaching to the students, when you are discussing this question, explain to them, tell them the formula and how to calculate, explain to them so that they can remember. They are very simple things, but the students, they commit mistake in the examination. The minimum distance between the object and real image in a lens. What is the minimum distance between object and real image? What is the minimum distance? You take a convex lens, object on this side, image on this side. What is the minimum distance between the two? What is the, this is a very important question. Remember, the minimum distance, if you place the object at 2f, the image will form that 2f. So real image will form that 2f. So what is the minimum distance? Minimum distance is how much? 4f. Minimum distance is 4f. Remember this. The choices are given 2f, 5f, 4f, f by 2. So the minimum distance is 4f. Remember this. Power of a lens of focal length 10 centimeter is 0.1 diopter, 10 diopter, 0.01 diopter, 1 diopter. Focal length is 10 centimeter. Questions different out. In the first question, power is given. The students were asked to find out focal length. In the second question, focal length is given. Now you are asked to find out the power. 10 centimeter. Focal length is 10 centimeter. Power is equal to what? 1 by F. 1 by 10 by 100. That is 10 by 12. Length is 10 by 12. Power is 10 by 12. A well-cut diamond appears bright due to what? These are important questions. I have selected some most important MCQs for discussion because these questions, when questions are asked, normally these questions are asked MCQs from array of text. The well-cut diamond appears bright due to number 1, refraction, due to scattering, due to total reflection, none of these. So which is the correct answer? Either a well-cut diamond dazzles, or appears bright due to refraction or scattering or total reflection on all these. The answer is that total internal reflection. Because that diamond is cut in such a way that light falls on it at an angle greater than the critical angle. And the condition for total reflection is that its angle of incidence must be greater than the critical angle. So the angle of incidence is more than the critical angle. So total interreflection will take place. So maximum light, 100% of light will come back. So it will dazzle. So remember, answer must be remember. The student tell them to remember it. Well-cut diamond appears bright, or a diamond dazzles, same thing. Question may come, diamond dazzles or a well-cut diamond appears bright due to what? Refraction, scattering, total reflection, none of these. Answer is total internal reflection. Another question is there. The speed of light in air is 3 × 10⁸ meters per second. Total speed in diamond to refractive index is 2.4. I've already told you the concept of refractive index and velocity of light. These are simple things, but the students should understand and remember. Speed of light in air is 3 × 10⁸ meters per second. 3 × 10⁸ meters per second. Refractive index of diamond is 2.4. Mu 2.4. What is the velocity of light in diamond? You know that mu is equal to what? dA by dD. Velocity of light in air, the velocity of light in diamond. Velocity of light in air. Velocity of light in diamond. Simple, but if one remembers it, it becomes easier for him. If one doesn't remember it, it becomes very difficult for him. 1 mark question, if one knows it, answer can answer in 1 second. If one doesn't know it, he may take half an hour but cannot answer the question. That is the importance of MCQ. So MCQ must be factorized. Mu is dA by dD. That's why, because of MCQ, students are securing almost 100% in physics. Those are preparing well, they're securing 100% marks in physics. A subject where a student can secure very high marks. If he doesn't read, then he cannot secure even a single digit mark also. So in that case, dA by dD, dA 3 × 10⁸ meters per second by dD, value is 2.4. dD, velocity of light in diamond, the question is like this, meters per second. And if you calculate it, 3 by 2.4, calculate it. The answers are given 3 × 10⁸, 332, 7.2 × 10⁸, 1.25 × 10⁸. Definitely, the last answer will be correct answer, 1.25 × 10⁸ meters per second. Next question is, in optical fiber, from optical fiber, you may get a very MCQ, not long question or short question. In optical fiber, which of the following principle is used? Very important question. If a question comes from optical fiber, this question will come. Or what happens in case in an optical fiber? In optical fiber, which of the following principles is used? Scattering, refraction, total reflection, none of these. In optical fiber, total interreflection takes place. Next question is, it is possible to observe total reflection when a ray of light travels from total reflection is possible. Question must be read carefully. Question is, total interreflection is possible when ray of light travels from air to water, air to glass, water to glass, glass into water. Remember, first of all, total interreflection. You know the conditions of total interreflection. Light must travel from a denser medium to a rarer medium. The question is, total interreflection is possible when here we will search. In which case, light is traveling from denser medium to a rarer medium, air into water, rarer to denser, air into glass, rarer to denser, water into glass, rarer to denser, or one glass into water from denser to rarer. So this is the correct answer. Another important question is there. At sunrise and sunset, the sun appears red. Because this question comes very often. At the time of sunrise and sunset, we see sun appears red. What is the reason? The number of choices are given. The sun is coldest at these times. The sun is hottest at these times due to scattering of light. If this is due to effects of reflection, these are the different choices given. At the time of sunrise and sunset, the sun appears red due to what? The correct answer is due to scattering of light. Scatter. What is the meaning of scattering of light? We see something. So we see the sky, all the things. By what? By scattering of light. When light comes, it gets scattered by the atmospheric particles. And according to Rayleigh's criteria to the scattering, amount of scattering is inversely proportional to wavelength. Amount of scattering is proportional to 1 by lambda by 4. Proportional to 1 by lambda by 4. So which light will be scattered more? Which color will be scattered more? The color whose wavelength is maximum or minimum. Whose wavelength is maximum? Which color will be? The least wavelength will be scattered, gradually scattered and scattered. So ultimately, which color will be there when you see it at the time of sunrise and sunset? The sun is comparatively at a longer distance from us. So light is coming from the sun, gradually different colors will be scattered. So the color having maximum wavelength will be least scattered, will not be almost scattered. So which color will be there? Remaining color, which will be what? Remaining color will be what? Red color. That's why when we see at the time of sunrise and sunset, the sun appears red. Similarly, same question, same thing can be given. Red color is used as a danger signal. Why? Why you use the red color as a danger signal? Not blue color or yellow color, but red color is used as a danger signal. Because the danger signal, suppose danger signal is there, it must be seen from a long distance. So that you must be able to see it from a long distance. You can see means what? Light must come from that and to enter into the eye. Then you can see it. So when light is coming from there, it is getting scattered. So which components will be scattered more and more? The components having less wavelength will be scattered more and more. So which will remain will not be scattered. The component having maximum length will not scatter. Which component has the maximum length? Red color has got maximum. So red color will not. So red color will be remaining. Other colors will be scattered. That's why red color is the danger signal. Now, what is the reason for the blue color of the sky? This is important MCQ asked. The blue color of the sky is due to red light is absorbed, blue light is scattered, blue light is absorbed. It is natural color of the sky. Which is the correct answer? Blue color of the sky is due to red light is absorbed, blue light is scattered, blue light is absorbed. It is the natural color of the sky. You see the atmosphere. How? When light is coming from the sun, gradually different components are getting scattered by atmospheric particles. Which components are scattered maximum? The component having least wavelength. According to less scattering, the amount of scattering is proportional to 1 by lambda to the power 4. So when lambda is less, scattering is more. So for that purpose, which color will scatter more? Blue color will scatter more. When blue color will go to up, we see the sky appears. So sky appears blue due to what? Due to because blue light is scattered or due to scattering of light. Another question is from that same question can be asked in a way. In absence of the atmosphere, sky will appear red, blue, dark, white. If the atmosphere were not there, the sky would have been what? Red, blue, dark, white. Suppose there is no atmosphere. What will be the color of the sky? If there is no atmosphere, there will be no scattering. Scattering takes place in high atmospheric particles. When atmosphere is not there, there will be no scattering of light, so there will be no blue color. So sky, in absence of atmosphere, the sky will appear what? The sky will appear what? No scattering, sky will appear dark. Do you know that? In absence of atmosphere, sky will appear dark. Mirages are formed in desert due to what? Mirages are formed in desert. And due to what? Interference, diffraction, dispersion, total internal reflection. How the mirages are formed in desert? Mirages are formed in desert due to total internal reflection. In this case, when you see how the mirage is formed in a desert, why do we imagine in a desert there is scarcity of water? So when due to total reflection, inverted image of trees form. When inverted image of a tree is formed due to total internal reflection, the Karavan thinks as if water is there and inverted image of it is formed. So he runs to the spot to get water. But to his utter surprise, he finds no water there. That's why it is called mirage. And that happens due to total internal reflection. So total internal mirages are formed in the desert due to total internal reflection. Now we can come to some numericals also with may come in MC. Also in some question, mostly in MCQ also you can get. The question is, what is the focal length of double convex lens or with radius of curvature each surface is 40 centimeter, refractive index mu is 1.5. The radius of curvature of each surface is 40 centimeter. Refractive index is 1.5. What is the focal length? 40 is the focal length of the double convex lens. These type of questions are very, very important. How to solve this question? This can be solved by lens method formula. What is lens method formula? 1 by f is equal to what? U minus 1. 1 by r1. This is the formula. Your mu is given, radius of curvature is given. Now you can calculate. R1 given, R2 given, mu is given, calculate. All these things are given. This can come in as a numerical. Also, this can come as a MCQ also. How to calculate? Radius of 40 centimeters is a double convex lens. What is the value of R1 and what is the value of R2? R1 is 40 centimeters like you see, double convex lens. But explain to students like this. Both these sides have got same radius of curvature. This side 40, that side 40. But what are 1 minus 1 by 40 this becomes 0? Not that. This side 40, this side minus 40. This is very important. Minus 4. So 1 by f is equal to what? 1.5 minus 1 into 1 by 40 across 1 by those plots. So this becomes what? 0.5 into 2 by 40, that is 1 by 20. So if you know how much? Dy 0.5. 40 centimeter. Process are giving 50 centimeter, 40 centimeter, minus 30 centimeter, and minus 40 centimeter. The answer is 40 centimeter. 20 by 0.5 and 40. This type of question may come. So you have to see what is the value of R1, what is the value of R2. Suppose it is given a planar convex lens has got radius of 40 centimeter. plano-convex lens made of glass has got radius also 40 centimeter. Then what is this focal length? That was very important. Plano-convex lens. Plano-convex lens. Plano-convex lens means what? One side plane surface, the other side convex surface. Plano-convex lens. So suppose the question is given, radius of vector is how much? R is equal to, say, for example, 40 centimeter. Refractive index is equal to 1.5. The question is, in the previous question, it was a double convex lens. Here it is given a plano-convex lens. So how to answer this question? So what formula will be? Same formula. 1 by f mu minus 1 into 1 by r1 minus 1 by r. So what is r1? What is r2? Only radius is given 40 centimeter and the plano-convex lens is there. So this is 1.5 minus 1. This is 1 by 40 minus what? 1 by infinity, or you can take 1 by infinity minus 1 by 40. Plano-convex surface 1 by infinity. This because you can take it like this. Plane surface, radius surface how much? Infinity. Convex lens on this way, we have this form like this. So this becomes what? Plane surface 1 by 40 minus 1 by 6, this becomes what? Infinity. 1 by 40 0. So this becomes what? So this becomes 0.5. 48.5 if you got what? 80. Plano-convex. Plano-convex lens means one surface is plane, the other surface is convex. Plane surface, radius is how much? Infinity. R is equal to infinity. Other radius is there. So the another question, very important question is there. A convex lens is dipped in a liquid whose effective index is same as that of the material of the lens. The lens behaves as a convergent lens, a divergent lens, a glass plate, a prism. It's a very important question. A convex lens is dipped in a liquid of refractive index same as that of material of the lens. Lens will behave as a convergent lens, as a divergent lens, as a glass plate, as a prism. So what is the answer? What is the answer? Now you are dipping the convex lens in a medium whose refractive index is same as what? Same as that of the lens. So how to solve this problem is very important. Every student will remember this answer. The lens will behave as a glass plate. It will behave as a glass plate. How it will behave as a glass plate? How it will behave as a glass plate? You see, 1 by f u2 will be 1 minus 1, 1 by r1 minus 1 by r2. This is the formula. Like this formula to solve. Now you are putting the convex lens in the medium whose refractive index is same as that of the lens. That means mu2 is equal to mu1. Mu2 is equal to mu1 means what? Mu2 becomes equal to refractive indices are equal. So in that case, because mu2 will be 1 minus 1 0, so that becomes 1 by 0 is equal to what? 5 becomes infinity. So focal length becomes infinity means it behaves as a what? Behaves as a glass plate. Tell the student, remember this question and remember the answer because it is a very important question. A convex lens is dipped in liquid of refractive index, same as that of the material of the lens. The lens will behave as a convergent lens, divergent lens, glass plate, and a prism. It will behave as a glass plate. There can be other number of questions also. Least distance of distinct vision for a normal eye. Choices are 15 centimeter, 10 centimeter, 25 centimeter, 35 centimeter. So least distance of vision for a normal eye. Remember, it is always 25 centimeter. Least distance for a normal eye. The image formed by simple microscope. Number one, real and erect, real and inverted, virtual and erect, virtual and inverted. So what is the nature of image formed by a simple microscope? Real erect, real inverted, virtual erect, virtual inverted. Which is the correct answer for this? This is virtual and erect image formed by a simple microscope. So these are some MCQs which can be asked for reflection of light. In addition to this, there can be number of MCQs, not that these questions will suffice. They are not sufficient number of MCQs, but if a student reads the chapter thoroughly, he can answer all the MCQs. Thank you all.
Dear colleagues, we come to the end of the first session. Now within 2 to 3 minutes, we'll start the second session. Now, the second topic to be delivered by Dr. Prafulla Kumar Misra, retired principal, SCS College Puri, is already there. So now I am requesting Dr. Prafulla Kumar Misra to take over this deliberation. ଆପଣ ଗୋଟେ କାମ କରନ୍ତୁ, ୟାର ଫଟୋ ନେଇଯାନ୍ତୁ, ପଠେଇଦେବେ, ୟାର ଫଟୋ ନେଇଯାନ୍ତୁ, ଆଜି ପଠେଇଦେବା ପରେ
ବ୍ଲାକବୋର୍ଡ କରି ଭଲ ଅଛନ୍ତି। ମୁଁ ମଧ୍ୟ ପଢିଲି ସେଇ କୋଭିଡ ପଢିକି କଷ୍ଟ ପାଇଲି ଆଉ। Dear teachers and my friends, so I have been assigned two topics. One is the from electromagnetic induction, and the other is the dual nature of light and metal. So, as per his instruction, there will be MCQ questions to be discussed from electromagnetic induction chapter. So, I have prepared some questions from a book that is a good book, Satya Prakash, Bipin Patnaik and Rajat Man Singh. Mainly Satya Prakash book, which is from Delhi side. So, other books are also there. So let us start about the Faraday's laws, induced EMF and current, Lenz's law, eddy currents, self and mutual induction. So mainly the questions that I see are from Faraday's laws and self and mutual inductions. So let us start with the first question. These will be given to the students after the class also. The first one is, they say that the inductance of a coil is directly proportional to its length, the number of turns, the resistance of the coil, the square of the number of turns. But as you know, from the derivation of expression for self-inductance of a circular coil, the expression is L is equal to mu0 by square 2. So from this expression, you see that the self-inductance L is directly proportional to the square of the number of turns. So the answer will be D. Then the other question is, self-inductance of a solenoid of length small l and area of cross-section capital A with a fixed number of turns, capital N, increases as. So that is given in the NCERT also, that has been mentioned. So let me write the first the expression for this solenoid expression. This is for circular coil. This is for solenoid. Expression for self solenoid. So that, as you see from the expression, second expression, so it is, there are four choices. So increases as is given, and L and A increase, L decreases, A increases, L increases and A decreases, both L and A, small l and A decrease. So you see from the expression, that is, from the first expression itself, we see that this small l decreases, then L will increase. If A increases, L increases. So the choice will be the choice will be um, B, that is L decreases and A increases. Here, so this is for the solvent. So that expression has to be remembered because that is the derivation, not very large derivation, but one should know the expressions also for competitive examinations. Then the physical quantity expressed in Henry is. It is very simple. The actually in some questions they write self-inductance, mutual inductance, both self and mutual inductance like that. But here in this question, they've given magnetic flux, self-inductance, magnetic permeability, magnetic induction. So therefore, we will just write self-inductance, that is B. So next question is B. Then the next question is, when current in a circuit drops from 10 ampere to 2 ampere in 2 seconds, the induced EMF developed in the circuit is 16 volts. The self-inductance of the circuit is. So here you have just to use that expression that E EMF is equal to minus L di by dt, that is delta I by delta. This negative sign, for magnitude, sake of magnitude, you can ignore the negative sign. So it will be 16 volt. That given. It is 16 volt and 10 ampere to 2 ampere. 10 minus 2, that's delta I in 2 seconds. So from this you see that L is equal to so L is equal to 4. That is the choice. The other things are there. Some 8 Henry, then 16 Henry, like that. So result is 4 Henry, that is D. Unfortunately, in this book, the printing mistake, they write B, but this will be D. Then the next question is, the current passing through a choke of self-inductance 5 Henry is decreased at the rate of 2 ampere per second. The induced EMF developed across the coil is 10 volt minus 10 volt, 2.5 volt minus 2.5 volt. Here also the result is wrong actually, because you see that induced EMF developed, they ask E. Same formula. This formula minus L is given to be 5 Henry. So here, if you take the decrease as negative, there is a decrease by a rate of 2 ampere per second. And if you, this will actually ask about the magnitude of the induced EMF, because that will be much clear. When you say conventional, you are using decreasing means minus or increasing means plus. So there, the two answers are there, 10 volt and minus 10 volt. So that is confusing. So therefore, the modulus should be written. So then the next question is, Lenz's law is a consequence of the law of conservation of
energy.
Momentum, mass, energy. It is energy. It's very simple. Because unless you do work, there will be no production of induced EMF. So it will be energy. Then we come to the next thing. That is 766. There are some simple questions and also some typical questions. So that is, say, whenever, then the next question is, whenever the flux linked with a circuit changes, there is an induced EMF in the circuit. This EMF in the circuit lasts. There are four choices: for a very short duration, for a long duration, forever, as long as the magnetic flux in the circuit changes. So usually one write for a very short duration. That is also correct. But as long as the magnetic flux in the circuit changes, that is more correct. Because as long as flux is changed, so you will have induced EMF. So that is D. Answer is D. Then the next question is, the area of a square-shaped coil is 10 to the minus 2 meters square. Its plane is perpendicular to a magnetic field of strength 10 to the power minus 3 Tesla. The magnetic flux linked with the coil is. As you see, it is flux, magnetic flux definition, you know, BA cos theta. For uniform field and also plane area, that is applicable, BA cos theta. And if it's not inclined, that is perpendicular, so there will be cos theta is 1. So it is BA. So the answer is BA. So 10 to the power minus 5. That is the answer. And the unit is Weber, because it is MK system. So meter and Tesla, those things are there. So it is Weber. So 10 to the minus 5 Weber. Then go to the next one. An area situated in a uniform magnetic field B is 4 Weber per meter square, and its normal makes an angle of 60 degree with the field. The magnetic flux passing through the area A would be equal. Here it is area B, normal to the area the flux ion is B theta. The theta value, that is angle made with the normal. So it is BA cos theta, and if you put the values for B and for A it is 0.5, then there is cos theta is half. So you get 1 Weber. That is the answer. There are other choices also. So 1 Weber is the second one, B. That is answer. Then there is another question. If the number of turns in a coil is doubled, then its self-inductance becomes. You see, from the coil means circular coil, they mean. So there is n square. So if n is doubled, then naturally the self-inductance becomes 4 times. So that is number of turns in a coil is doubled, then its self-inductance becomes 4 times. That is C. C is the correct answer. There is also half, double, and on change like that. So it is 4 times. Then another question is, a magnet is dropped with a north pole towards a closed circular coil placed on a table. Looking from the above, the choices are, looking from the above, the induced current in the coil will be anti-clockwise. The magnet will fall with uniform acceleration. The magnet falls, the acceleration will be reduced. No current will be induced in the coil. Actual answer will be looking from the above, the induced current in the coil will be anti-clockwise. Because as you see, this diagram, Coil. This is the coil. You see on this side, this current will be anti-clockwise. Induced current will be anti-clockwise. So that is because the appliances from this one, that when n goes downward, then the number of magnetic lines of induction associated with the coil will increase. That has to be opposed. So the circuit prepares opposite lines of force. So when you look from the top, opposite lines of force can be produced only when there is anti-clockwise current in the secondary. This is the secondary coil. Actually, coil should be closed. I have not shown. It should be closed. Unless anti-clockwise current is there, upward lines will not be produced. So those lines will oppose the original lines. That is the idea. Copper ring is horizontally, and a magnet is dropped through the ring with its length along the axis of the ring. The acceleration of the falling magnet, there is 4 choices: equal to that due to gravity, less than that due to gravity, more than that due to gravity. Depends on the diameter of the ring and the length of the magnet. So here the answer will be less than that due to gravity, because when the magnet falls, it is not only just a material, so it is a magnetic thing. So therefore there is a upward push by the magnetic lines of induction also. So therefore the not exact gravity will help. It will be less than that due to gravity. So then we come to the next question. Lentz's law is essential for conservation of energy, conservation of mass, conservation of momentum, conservation of charge. It is conservation of energy, as we have already discussed previous questions. Then there is a very interesting question. You see, the question is: a thin circular ring of area A is held perpendicular to a magnetic field of induction B. A small cut is made in the ring, and a galvanometer is connected across its ends in such a way that the total resistance of the circuit is R, capital R. When the ring is suddenly squeezed to 0 area, the charge flowing through the galvanometer is. It is actually for competitive examination, this type of questions are asked. For council examinations, this type of questions are not asked. Rather simple things are asked. But still then, it is there and we can discuss it. So you can see that what is the expression for induced gain. Minus sign I have ignored. So E is equal to d phi by dt. And your current will be that is 1 by r d phi by dt. So Q will be that. That is I. So it will be d phi I dt by r. So when the area, you see the area into magnetic induction, that is flux. So First, there is flux is BA. Flux is BA, then that is just becoming 0. BA, it is say the suddenly squeezed to 0. Area is squeezed to the change in B time will be just BA minus B. So magnitude is 1. So that is your BA by R. So the choice is B. There are 4 choices. One is BR by A, then there is BA by R, there is ABR, there is B square A by R square. So they are just new usual questions are not there. So then you come to the then inductance. Next question is inductance plays the role of there is inertia. A is inertia, B is friction, C is source of EMF, D is force. So here, how we know that inductance is inertia? Correct answer is inertia. So there is actually this is self energy. There is an expression for self energy. It is not in the syllabus, but that is there. Self energy due to presence of self inductance is and there is also, half mv square. Half mv square. Mechanical. For mechanics, it is half mv square. Or for rotational motion, it is half I omega. So from these expressions, we see that N is the mass. That is also called inertia. And it is the moment of inertia for rotational motion. So in analogy with this, they write L as the inertia. For this type of circuits where self-inductance is present, L plays the role of inertia. Then we come to the next question. When current in a coil changes from 8 ampere to 2 ampere in 3 into 10 to the minus 2 seconds, the EMF induced in the coil is 2 volt. This self-inductance of the coil. We just this formula is applied. So you get the correct answer as 10. That is 10 millihenry. So that millihenry you have to write because L is you are getting L as 10 to the power minus 2 Henry. To make it millihenry, you see. So therefore, milli and that means you have to convert to milli. That is the only thing to be noted here. Then the next question is when the current in a coil changes from 2 ampere to 4 ampere in 0.05 seconds, the EMF induced in the coil is 8 volt. The self-inductance of the coil is the same thing, same formula used. So there are 4 choices. The answer will be B, that is 0.2 Henry. Then we come to the next question. Next question is the mutual inductance of 2 coils depends upon medium between the coils, separation between the coils, both A and B means medium and separation. Then D is none of A and B. So here the answer will be mutual inductance, as you know, depends on the rate of change of current in one circuit, and the effect is found in the other circuit. That is there. But here in these 4 answers, you get medium between the coils. Medium, it actually depends, and separation in the coils also depends. But the separation is close, it is close, then it is more effective. So the answer will be both A and B. Both A and B. That answer will be both A and B. Then we come to the next question, that is, if capital L and capital R represent inductance and resistance respectively, then the dimension of L by R will be. Actually, to find this L by R ratio, what we do? You can see the it is, I think you know how to find the dimensions. It there in this book also. Dimension of L you write and dimension of resistance you write. I have checked. It is all right. So the ratio will be just T, means time. L by R, the ratio is M0 L0 T. So in this question, it is C. Answer will be C. Clear? So L by R, that is also called say time constant. That is there in the, there is a theory for growth and decay of current. So there L by R is taken as time constant. So that is time, the dimension of time. Then he writes dimension of the quantity L by R CV are those of, they write four things: charge, charge inverse, current, current inverse. So it is just a application of the previous one. L by RC by resistance voltage. So what is the dimension they ask? So immediately we will apply the other one. L by R, it will be T time. Clear? Then for CV, what to do? Capacity C is equal to P by. So CV will be Q. So Q is now. This is right. This by Q. And this will be written 1 by Q by T. Q by T is what? Rate of flow of charge. That is what? T1 by. Yes. So it is coming out as 1 by current. So the choice will be D. Current inverse. That is 1 by current, current inverse. Then you come to two coils of self-inductances, 2 millihenry and 8 millihenry are placed close to each other, such that the flux linkage is complete. That means the lines of force of one enter completely into the other area, and vice versa. The mutual inductance between these coils is. So there what you do, you need not find all these details of the expressions for mutual inductance. Like there is one thing that is called coefficient of coupling. N is equal to A. That L1, L2. L1, L2 are the self-inductances of the individual coils, and K is called coefficient of coupling. So here, for complete linkage, K is 1. Complete linkage. K is 1, and you have N is equal to L1, L2. It is 2 millihenry. 8 milli. 2 to 8 is 16. 16 is 4. It is 4 millihenry. I think you follow it. So this expression you may not know, it might not have come across, but it is there. Mutual inductance. And then next we come to there are many questions on the alternating current also, but that is not given to me. So I have to skip over. Then 50D. It is actually now it is a very interesting problem. So he says that a conducting circular loop is placed in a uniform magnetic field of 0.04 Tesla with its plane perpendicular to the magnetic field. The radius of the loop starts shrinking at 2 millimeters per second. The induced EMF in the loop when the radius is 2 centimeters is, there are 4 choices. Some microvolt, always is microvolt is given, 4.8, then 0.8, 1.6, and 3.2 like that. So let me work out this problem for you. So here you see E is equal to defined by dt. So how much it will be? What is flux there? Flux will be magnetic field, that is Tesla, 0.04. Then area area is distance. Hello? Induced EMF is equal to defined by dt is equal to I is dA. I is dA, which is b the a by dt. It will be d by dt of this one. Here, flux is just differentiated. So we get 2R dr, right? So this is the rate of shrinking of the radius, which is given to you as 2 millimeters per second. 0.05 into radius is 2 centimeters. 500 meters. This is 2 millimeters. 2 into 10 to the power minus 3 per second. So if you put all these values here and calculate it, it comes out to be 3.2 into 10 to the power minus 6 in that. Look at the minus 3, then 10 to the power minus 6 like that. Those things they together. 6, then 5, two, 5, 8, 4. There are 4 choices. One choice is there, that is D, 3.2, that is D. Then we come to the next engineering. You see, there are other sets of things. Two coils are placed close to each other. The mutual inductance of the pair of coils depends upon the materials of the wires of the coils, the currents in the two coils, the rates at which currents are changing in the two coils, relative position and orientation of the two coils. Here you see there is confusion, little bit confusion. In C, they write the rates at which currents are changing in the two coils. One may think this is correct, but it is not exactly correct, because the mutual inductance means rate of change of current in one of the coils. That how that is affecting the other. So not the rates at which currents are changing in the two coils. So therefore, the fourth is more appropriate. Fourth is relative position and orientation of the two coils. Relative position and orientation of the two coils. Then, why there is orientation? You see, suppose coils are in such a position that the magnetic lines of one completely enter the other. But suppose the coil is tilted, so that there will be difference. So similarly, the position means separation. Position may be very close or very not very far away. If very far away, then the result will be almost zero. So that is there, position and orientation. Then the next question is, same, a circular loop of radius capital R carrying current I lies in XY plane with the center at origin. The total magnetic flux through XY plane is directly proportional to I, directly proportional to R, directly proportional to R square, then 0. You see, it is very simple, because circular coil means the area is pi R square, pi capital R square, and flux is BA. If it is exactly perpendicularly entering, then it is BA. So it is B into pi R square. So naturally, the flux is proportional to the flux will be to XY plane. Here they have not mentioned about the direction of B, but that has to be considered as perpendicular to it. So naturally, it is directly proportional to the R square, radius square. Then there is another interesting question, that is a rod of length L takes out a magnetic field with a velocity V in a direction as shown. The induced EMF in the coil in the rod is. See, there is one thing that is called translational EMF, or in some books it is written motional EMF. Motional. These cross lines, they indicate magnetic field into the plane of the. Here you see, suppose the this here induced EMF is minus BLB, or if you take modulus only, it is BLB. So it is moved this way. It is B, trying to go away from the field, like. But here in this diagram in the book, what they write, See, here, if you resolve this configurative vector, to resolve this one, or the resolve velocity also same thing. It is this one. The perpendicular will be, it will be sin theta, L sin L cos theta. This will be L. So instead of L, it will be L sin. Will be E will be minus E L. So because the derivation was made when L was perpendicular to the magnetic field. So here you have to take the perpendicular component of L, or if you resolve the velocity, it will be V cos theta, of course, and V sin theta again, same thing. So it will be BLV sin. In this book, it is they have given only BLV sin theta, minus sign they have ignored. That is the convention due to Lenz's law, minus sign is given. So it is not considered. Then we come to the T1. So that is it is also a new type of problem given. A coil of area 5 into 10 to the minus 3 meter square is placed perpendicular to a time varying magnetic field shown in the figure. The value of induced EMF in the coil in 10 millisecond is given. So they have given a graph. The magnetic field is B function of time, and the this time is in millisecond. You look at millisecond. Tesla, I think. Tesla is there. Straight line graph. So it's 10 millisecond. At 10 millisecond, it is a point. You see from this graph that the time is 10 millisecond, the value of B is 2 Tesla. That is given. And what they ask is value of induced EMF in the coil in 10. So what is the flux now? The flux will be the flux is now 10 millisecond. The flux is this much. So phi. So and E is equal to d phi m by dt. So this point to coil of area. Flux is dA. Flux is B. That is B. Area is not 10. time is 10. So area they have given is 5 into 10 to the minus 3. It is, 5 into 10 to the minus. So this is your cross B. And in this case, define this one. Then dt is your candidate. So it is now volt. So the magnitude will be 0.1. Indirect choice is 0.1, 0.1 millivolt, 0.5 millivolt, 0.5 millivolt, like that. So this is a new type of problem. And next we come to when the current changes from 2 ampere to minus 2 ampere in 0.05 second, an EMF of 8 volt is induced in the coil. The coefficient of self-inductance of the coil is. It is quite simple. Say, previously we have written that formula also. Break कर दो. So let us have a small break of 5 minutes. let us begin the discussion. You see, when the current changes from 2 ampere to minus 2 ampere in 0.05 second, an EMF of 8 volt is induced in the coil. The coefficient of self-inductance of the coil is, it is just the same, E is equal to L di by dt. Same formula. Only delta I you have to take 2 minus of minus 2. That is 4. So if you take delta I is equal to 4, then time is 0.05, voltage is 8 volt, E, then you find L as 0.1 Henry. That is first A is there, 0.1 Henry. Then similar question is next one, an EMF of 100 millivolt is induced in a coil when current in neighboring coil becomes 10 ampere from 0 to 10 ampere from 0 in 0.1 second. Then the coefficient of mutual inductance between the two coils will be. The same similar type of thing, only thing is the formula. It is N, LDN N, delta I2 by delta T. E1. This EMF in the first circuit due to current change in the second circuit. That is to be only introduced. So EMF of this much millivolt. This is 100 this much volt. Then there is M. Then delta I2 is 10 ampere from 0. Is 10 in 0.1 second. So that will be 1 by 10. 1 by 10. 10 and 1 milli. Yeah. So this is the first one, that is 1 million in, and 10 million in, 100 million. So the next one, this one. So this is the last problem on this chapter that I have chosen. So this is very interesting problem. The magnetic flux linked with a coil at any instant is given by the magnetic flux phi is equal to phi m actually 10 t square minus 50 t plus 2. Yeah. So he says that define the induced EMF at time t is equal to 3 seconds. So induced EMF E minus pi by 2. If you differentiate this one, you get as minus 150 0. So at t is equal to 3 seconds, it should be d is equal to 16 plus 2 and with this minus. Then is the clear. So this is the last question that I have selected, and then we come to the multiple choice questions on dual nature of light. That will also proceed to some extent. And the next class that is given in September, we will discuss the long questions on this dual chapter. So today we'll discuss some MCQ questions. That is about let us start with the dual nature of light, which is in actually part 2 that is there. So there may be MCQ and also the long questions will be there. Long questions we will discuss in that class. But today we will proceed to some extent about the dual nature of light. So that chapter I think you know. That is the main thing is about de Broglie's matter wave and then Einstein's photoelectric equation, that type of things. So the first question is, a particle is dropped from a height h. The de Broglie wavelength of the particle as a function of height is proportional to, there are 4 choices, h root over, then h to the power 0, h to the power minus half. So this is given in NCERT exemplar. So you see, in mechanics, you know, when the body of mass m got the height h, then the velocity with which it reaches the ground is 2gh root. You apply just v square minus u square to s formula, you get it. So what he says is the de Broglie wavelength at the ground. So here it will be lambda is equal to h by m, h by m, h by m into 2gh. Here the symbol in that book, capital H is given. So h by m Then H to the power minus. The H root over is in the denominator. It is actually H to the power minus half. So it will be, answer will be D, H to the power minus half. Then the next question is the wavelength of a photon needed to remove a proton from a nucleus which is bound to the proton from a nucleus which is bound to the nucleus with 1 million electron volt energy is nearly. You see, he wants to create confusion in that NCERT and exemplar book. So what he says is one has to find this proton separation energy. That is not required actually, because he says that 1 MeV is needed. That is given to you. So 1 million electron volt is needed. That is known to you. That is energy. So once energy is given, then we can find the wavelength. See, yes. Energy is lambda. So lambda will be so H is 6.63 Joule second, and it is 3 into 8. Energy is 1 into 10 to the 6, that is million. Electron volt is 1.6 into 9. So this must be. So if you just calculate, it's not difficult. I have done it. So it comes out to be 1.24. Into 10 to the power minus 12 meter. But he wants to expression nanometer. So what will be? This is the nanometer. So that is found out. Then we come to the third one. Third one is there is no numericals. He says consider a beam of electrons, each electron with energy E0, capital I0, incident on a metal surface kept in an evacuated chamber. Then he says no electron will be emitted as only photons can emit electrons. Electrons can be emitted, but all with an energy E0. Electrons can be emitted with a knee energy with a maximum of E0 minus phi. Phi is the work function. Electrons can be emitted with any energy with a maximum of E0. 4 choices are there. The third choice is correct because this is a metal surface. So electrons are falling with energy. So this electron that gets the energy on the surface can go out with Rm the mass square, which is equal to E0 minus phi. And here phi is equal to work function. Amount of work done by the electron to liberate itself. This is energy. Incident energy may be electron beam or photon beam, like that. Any incident energy. This is not that trying to create confusion. This is electron, this is electron, but this is incident energy. So maximum energy is not regulated by E0 minus phi. And if the centers into and gets the electron here, it will come out with energy R into square. So, what is the range of energy? Range of energy of this one is from half mv square to E0 minus 5. No question of E0. Only E0 cannot take place. Because the electron which is to be liberated has to do some work against the attraction of other nuclei on the surface. Then he says a charge Q contains electrons each of mass m. This charge is accelerated under a potential difference V. The speed acquired by the charge is, you see, there is a formula delta W delta electrostatics. This is there. Delta W is equal to Q delta V, and that is equal to how much? That is equal to delta E. This is work energy theorem. Work energy theorem is the amount of water is equal to kg and. So this Q is now N into E. He says that it contains n electrons. Delta V they have taken V, and this delta EK is your half mv square for one electron, and for n electron we need this one. So n will cancel out. So you have P small p is equal to 2 EG by n. Just they have created confusion by introducing n electrons, but it is for one electron. This formula you will know. Formula 2 EV by m root over. That is also true, and it is A. Answer is A. This is a council question, previous year council question. Then there is another question: is a photon with energy E is characterized by wavelength given by. Photon with energy E is characterized by wavelength given by. So here it is very simple. E by c square, E c square by h, E by sc, sc by E. It will be sc by E because you see lambda is equal to how much? Lambda is equal to E is equal to h mean, that is sc by lambda. So from that you get lambda is equal to sc by here. It is also a council question, previous year council question. Then you come to the next one, that is photoelectric effect occurs when the frequency of the incident light on the photosensitive material is dash the threshold frequency for the material. It is very simple because the threshold frequency is the minimum frequency, the incident light that is needed to have photoelectric effect. So the incident light should have frequency more than threshold frequency, because then the energy will be h nu, that is greater than h nu 0. So it is the blank is greater than, that is C. Choice is C. It is council question. Then you come to the other questions. other questions in multiple choice questions. Then we'll go to very quickly because these are simple ones. At first, it is very simple. As you see, the photoelectric effect is described as the emission of electrons from a surface of metal when A is it is heated to a high temperature, B electrons of suitable velocity impinge on it, C is light of suitable wavelength falls on it, it is placed in a strong magnetic field. You see, photoelectric effect is associated with incident light, maybe visible, maybe ultraviolet, X-ray, like that. So it is C. Answer is C. Then is photoelectric effect was discovered by Hertz, Halbach, Einstein, Millikan. Actually, Einstein explained it. So Hertz is regarded as the discoverer of photoelectric effect. A is correct. Photoelectric effect supports Newton's corpuscular nature of light, Huygens wave theory of light, then Maxwell's electromagnetic theory of light. Then in this book they write Einstein's quantum theory of light. Actually, it should be Planck's quantum theory of light, because Einstein used Planck's theory to explain it. Einstein is not the originator of quantum theory. So Planck's quantum theory. Clear? So it is D. Then the phenomenon of photoelectric effect was explained by Planck, Maxwell, Einstein both. Explained by Einstein. It is correct. Einstein is there. It is C. Then work function of a metal is minimum energy required to free an electron from the surface against Coulomb forces. Because the electron, when it tries to escape from the surface, has to struggle, has to do some work. And that is your work function. Others are not correct. Then photoelectrons emitted from a metallic surface are those which are present inside the nucleus, are orbiting very near to the nucleus, are generated by the decay of neutrons within the nucleus, free to move within interatomic spacing. So this is correct. Free to move within interatomic spacing, because present inside the nucleus does not possess electrons. That is one thing. Then are orbiting very near to the nucleus. So those electrons which are orbiting very near to the nucleus, they are strongly attracted, so they cannot escape. Are generated by decay of neutrons within the nucleus. Neutrons decay to protons and neutrinos, like that. So that is not correct. So there the nucleus is not going to break here when photoelectric effect takes place. So the fourth one is free to move within interatomic spacing. So those which are free and moving here and there inside the nucleus, inside the material, they are being ejected by the incident light. Then in photoelectric effect, next question, light energy is converted into heat energy. Light energy is converted into electrical energy. This is correct. Light energy is converted to sound energy. Electric energy is converted to light energy. Because light energy is incident, so there is no question of other things. Converted to heat energy, not correct, because the electrons are emitted, so current is produced. So therefore, B is correct. Then you come to next one, that is, which of the following phenomenon supports quantum nature of light? It is actually not in the syllabus, but one has to know for competitive examinations. That is interference, diffraction, polarization, Compton effect. You see, the particle nature of light is explained by photoelectric effect and Compton effect. So Compton effect uses quantum theory of light. That is there. One you should remember Compton effect. Then the next question is also on that. Compton effect is associated with visible light, X-rays, beta rays, positive rays. Compton effect theory in +3, it is there the detail. So there they use the X-rays. For X-ray it is applicable. So therefore the B is correct. Then we come to the momentum of a photon of wavelength lambda is given. Lambda is h by p. So p is h by lambda. So that is B. B is correct. Then Einstein's photoelectric equation is H nu is equal to H nu 0 plus half m mv square, half m v square. So that v square, but that's not correct. One should make v max square. So that is correct. Others are wrong. Then the photoelectric effect is based on the law of conservation of energy, because incident energy is equal to work done to liberate and then the kinetic energy. So it is based on the conservation of energy. Then you come to the next one. The unit of Planck's constant H is that of work, energy, linear momentum, angular momentum. It is actually a puzzling question. So I tried it and I got the answer, of course. What do you think of it? E is equal to H nu. That formula is well known. So H is 6.63 into 10 to the minus 34 joule second. Joule second means energy into time. So energy into time, and what is that dimension? Energy into time, you can say energy is work n L square t minus 2, then into time, then n L square, what you get? Energy into time. Energy is work n L square t minus 2 into time, so the n L square t minus 2. That we get angular moment. So H is equal to H dimension is equal to the dimension of H is same as angular moment. Then next we come to for light of wavelength 5000 angstrom, the photon energy is nearly 2.5 eV. For X-rays of wavelength 1 angstrom, the photon energy will be close to, you see there are 4 choices, and if you write just like say unitary method, that is ODR jota achi ये मेथड जोटा ऐकिक धारा पकेदेले होनी तेना 5000 एंगस्ट्रॉम रे एनर्जी है 2.5 eV तेणु 1 एंगस्ट्रॉम रे केते हो सेमति कले होनी तेणु एठी हम कोन करिवु व्हाट विल डू we will apply the principle like this. 2.5 eV is the energy when wavelength is 2.5 eV is the energy when so 1 eV 1 no they write same x eV x equal if you divide them, then you get so x means that energy, unknown energy. So that you get is 2.5 No. Sorry. Actually, when you write the equation, here you need to use this formula. E is equal to x mean is the so when you write 2.5 equal. This is not equal. This is just the expression. It is SC by some is there. Therefore, x is there, and when you write the equation, x is equal to xc. So when you divide 2.5 this by this one, and then in the xc cancels. So 1 goes off, 1 divided by. So therefore, when x is there, it is 2.5 into 5. The answer, this choice is there. 4 choices. One of the choices. X-ray has more energy. Logically, one can think that X-ray that wavelength is much less, but frequency is high. So therefore, energy is high. That is not divided by, that is multiplied. So the answer is C. 14C. Correct. In photoelectric effect, the next question. In photoelectric effect, when photons of energy h nu fall on a photosensitive surface, the work function is h nu 0. Electrons are emitted from the metal surface with a kinetic energy. It is possible to say that all ejected electrons have same kinetic energy equal to h nu by h nu minus h nu 0. You see this one. Only those on the surface will have this energy. All others will have not the same energy. Not it is not correct. All ejected electrons have it. Then B is the ejected electrons have a distribution of kinetic energy from 0 to h nu minus h. That is 0. Some will have 0 velocity because it is slow to h nu minus 1. That is possible. E0 is here, h nu minus h nu 0. So that B is correct. Then C, D, they are not correct. Then Einstein's photoelectric equation states that Ek is equal to h nu minus W. In this equation, Ek refers to kinetic energy of all ejected electrons, mean kinetic energy of emitted electrons, minimum kinetic energy of emitted electrons, maximum kinetic energy of the emitted electrons. So this is correct. Maximum kinetic energy, because I have written half and V max square. That has to be mentioned. They have not mentioned Ek. They write Ek, but that equation, Einstein's equation, here in this question, they write this as Ek. Ek is equal to here. It is incident energy. They write as h nu. That W is your work. Sometimes they write phi, sometimes they write W like that. Then another question, very well known, that is the rest mass of a photon of wavelength lambda is. You see, photons have wavelength. Photons have almost zero mass. That is called rest mass. Photons have rest mass 0, but they possess momentum. They are governed by this relativistic equation. P square C square plus M0 square. This is M0 is 0. So E is equal to PC. So they are governed by this equation. Then the interesting question is the next one. So photon have rest mass 0. That is this question. This question is photons have rest mass 0. That is A. A is photon is you have P square is equal to P square C square plus M0 square C4. M0 is known as the rest mass. Rest mass of the photon is 0. So that you have E is equal to how much? M0 rest mass of the photon. That is 0. So E is equal to PC. E is equal to PC. And this E for this one, you can E is equal to PC. E is equal to MC square. Okay? Equal to HC by lambda. This P, the lambda is equal to H by P, that is known. So P will be H by lambda. So it is HC by lambda. So from this you see C cancels. H by lambda. This is a new expression. Normally we don't use this. This is lambda is equal to M is equal to H by lambda C. Then we come to in photoelectric effect, the number of photoelectrons emitted is proportional to the intensity of the incident beam. That is A. Others are not correct. The intensity decides the number of photoelectrons that are emitted. But the velocity is decided by the frequency that you know. Then you come to the next one. The threshold frequency of potassium is 3 into 10 to the power 14 hertz. Then the work function is W is equal to what? Planck's constant, the H, and frequency is 3. So multiply, comes out to be 1.989 to the power -9. The answer is B. B is correct. Answer is. Then we come to the next question. The threshold wavelength for The threshold wavelength for photoelectric emission from a material is the threshold wavelength for photoelectric emission from a material is 5200 angstrom. Photoelectrons will be emitted when this material is illuminated with monochromatic radiation from a 50-watt infrared lamp, 1000-watt infrared lamp, 1-watt ultraviolet lamp, 1-watt infrared lamp. Here you see, you need not calculate anything because the wavelength that is given, threshold wavelength, that is the minimum wavelength for emission of photoelectrons is 5200. It is in the visible region. So if any infrared will fall on it, means more than this wavelength, then photoelectric emission will not take place. Because this is the threshold wavelength. You see, frequency besides the emission, wavelength this much means frequency will be less. So if you want to have more photoelectric emission, better photoelectric emission, then you have to use a ultraviolet light. So that the answer is C, that is 1-watt ultraviolet light. Here it is 1 watt only, but the wavelength is less, ultraviolet. Wavelength less means frequency more. The frequency more means more than threshold frequency. So you will have the 1-watt ultraviolet lamp. Then the next question is sodium surface is illuminated by ultraviolet and visible radiation successively, and the stopping potential determined. The stopping potential is, they write equal in both cases, more with ultraviolet light, more with visible light, varies randomly. So we have to first think of the expression for the stopping potential. Then only you can realize it better. So the definition says that stopping potential is the voltage or potential needed to stop the fastest moving photoelectron. The fastest moving photoelectron, I will see from this diagram here, happen E mass square. That is to be stopped by this voltage. This is known as stopping potential. So the stopping potential, as you see from this expression, V0 is depending on V max square. And here for the sodium surface, this work function is same for the ultraviolet and visible. And for ultraviolet, wavelength is less, but frequency more. So this one, work function for sodium, that is Na, for both ultraviolet and visible is the same. Work function is not changing. The characteristic of the substance. So if it is fixed, then naturally this energy of emission for the R and E max square for ultraviolet will be more than happen the max square or visible. And here you see from this one that V0 is proportional to G max square. That is V0 is greater than so velocity is higher for the ultraviolet, so the stopping potential is greater. Clear? So so V0 depends on V max, and that is why you have your B is more with ultraviolet light. Then the next question is X-ray are used to sorry, that question is not there. And then the next one, the strength of photoelectric current depends upon frequency of incident light, intensity of incident radiation, angle of incident radiation, distance between anode and cathode. So we come to this one. So here it is intensity, decides the number of electrons emitted. So number of electrons emitted will decide the current. So therefore, you have the answer B. Then the next question is photoelectrons are being obtained by irradiating zinc by radiation of 3100 angstrom. In order to increase the kinetic energy of ejected photoelectrons, first choice is intensity of radiation should be increased. No, intensity decides the number of electrons, not the velocity. The wavelength of radiation should be increased. Wavelength, if it is increased, then frequency will be decreased. Frequency will be decreased. So that is also not correct. And the wavelength of radiation should be decreased. So the frequency will increase. That is correct. So 26C is correct. Then the next question is, if photocell is illuminated by a small bright source placed 1 meter away, when the same source of light is placed 0.5 meter away, the electrons are emitted by the photocathode would increase by a factor of 4, decrease by a factor of 4, decrease by a factor of 2, increase by a factor of 2. So here actually a theory that is given, that is known in photometry, that was a subject previously in the syllabus when we were students. So that subject says that there is the inverse square law also applicable for the intensity of light. So in photometry, inverse square law is applicable. This means I is proportional to 1 by distance square. Maybe D also going to write D, so we write S also, the distance. So here it is first case, that is 1 meter away, the other is 0.5 meter. So let us write the I1. Will be proportional to 1 meter. The I2 will be, I2 becomes nearer. So I1 by I2 will be in the second case, intensity becomes 4 times, and intensity decides the number of electrons. So therefore, there will be increase by a factor of 4. First choice is increase by a factor of 4, and that is correct. Then there is other choices, they decrease by a factor of 4, decrease by a factor of 2, increase by a factor of 2, like that. So it is now increase by a factor of 4. That is correct. Clear? Then we come to the next question. The frequency and intensity of a beam of light falling on the surface of photoelectric material are increased by a factor of 2. This will increase the maximum kinetic energy of the photoelectrons. You see, there are 4 choices. I will just I will choose the correct one. The frequency actually decides the maximum velocity of the photoelectrons. And the intensity decides the number of electrons. So if both are doubled, then what will happen? Intensity doubled means number of electrons are doubled. Number of electrons are doubled. But frequency doubled means there is no effect of number of electrons. So therefore, the choice will be increase the maximum kinetic energy of the photoelectrons. Frequency doubled means there will be doubling of the, not doubling exactly, because the kinetic energy will be doubled. Increase, that is also not perfectly correct, because kinetic energy, if you see, incident energy minus pi, that is work function. So therefore, they write tactfully, increase the maximum kinetic energy. Kinetic energy will be increased, not exactly doubled. And photoelectric current will be doubled, because that will take place. Photoelectric current will be doubled, that is correct. The other choices are ambiguous. One can analyze deeply. When you see the question, I will give the questions to the authorities. They will send you the questions. So those are the right. Then the next question is, a photoelectric cell is illuminated by a point source of light 1 meter away. The plate emits electrons having stopping potential V. Then V decreases as distance increase. V increases as distance increase. V is independent of distance R. V becomes 0 when distance increases or decreases. You see, we can, if we apply the inverse square law, then what we find? That intensity, when it is brought closer, the intensity will be more. But intensity has nothing to do with stopping potential V0. Because you see, stopping potential is controlled by the Vmax square. Clear? So stopping potential is controlled by Vmax square, and Vmax square is controlled by the frequency of the incident light. So since there is no change in the frequency, so capital V0, that is stopping potential, in this question they write V here, does not change. So therefore the answer will be V is independent of distance R. Clear? Then you come to the next question. In a photoelectric experiment, the stopping potential for the incident light of wavelength 4000 angstrom is 2 volt. If the wavelength will change to 3000 angstrom, the stopping potential will be, here you see, wavelength is decreased. Wavelength decreased means frequency increased. So frequency decides the stopping potential. So previously the stopping potential was 2 volt. So now the stopping potential will be more than 2 volt. Because Vmax has increased, Vmax has increased. So the potential will be stopping potential that is needed to stop the fastest moving photoelectrons will be more. They do not say that exactly it is doubled or reduced 1/3 like that. They don't say. because there is a complicated relation according to Einstein's situation. This situation is a complicated one. So therefore, you cannot exactly say that it will be 4 volt or like that. It is just like say more than 2 volt. Then we come to the next one. In photoelectric effect, the work function of a metal is 3.5 eV. The emitted electrons can be stopped by applying a potential of minus 1.2 eV. Actually, stopping potential, we take modulus, that is your EV0. But to stop the electron, you need a negative voltage. You do not, you should not apply positive voltage. That will enhance the velocity. So therefore, it is minus 1.2 volt. But you see the 3.5 eV and the electrons are to be stopped, and the energy of the incident photon will be at that time how much? More than 3.5 eV, because energy is 1.2 electron volt. It is a applied volt. The voltage needed is 1.2 volt. That is, the V0 is 1.2. So EV0 means it will be electron volt. So that electron volt and this 3.5 have to be added. So it becomes 4.7 eV. So incident energy has to be 4.7 eV, so that the overcoming of work function will take place and the electrons energy will be 1.2 eV. 1.2 eV is stopped by minus 1.2, so it is 0. That becomes 0. So therefore, incident energy will be 3.5 plus 1.2, that is 4.7 eV. Clear? Then we come to the next one. Photoelectric cell converts electrical energy into light, converts light into electricity, stores light, stores electricity. Photoelectric cell actually converts light into electricity. It is like a solar cell. Solar cell incident light is converted to current, electric current. Then we come to the next one. The work function for a metal is 3 eV to emit a photoelectron of energy 2 eV from the surface of this metal. Photoelectron of energy 2 eV from the surface of the metal. The wavelength of the incident light should be. Here you see, as we have discussed in the other one, work function is 3 eV. So minimum energy needed is to eject an electron with 0 velocity is 3 eV. So you have some energy of the electron, that's 2 eV. So therefore 5 eV incident energy is required. So for 5 eV, you have the 5 eV, you have the h nu. For h nu 5 eV, what is the value of lambda? So for 5 eV, you see incident energy is E0. So that the electron is 2 eV and here W, that is work function of high, so that is high. So therefore 5 into 1.6 into 10 to the minus 19. So that is your incident energy, and that is equal to, let's see that. Let me get 86.3. To calculate lambda, it is coming out to be, I have calculated it, is 2480. 2480. But in that book, the printing mistake or something, say they write 2875 angstrom. Then the next question is 5. The work function of a photoelectric material is 3.3 eV. Its threshold frequency will be very simple. You see, work function is equal to h nu 0. So h you just use Planck's constant. Then you find the nu 0. Electron volt has to be converted, of course. 34B was there. Work you just use 35 is there. That you get it nearly 36. That is nearly equal to threshold frequency is 8 into 10 to the power 14. First one, A is correct. 8 into 10 to the power 14 hertz. And 30. Then the next one is ultraviolet radiation of 6.2 eV falls on an aluminum surface of work function 4.2 eV. The kinetic energy in joule of the fastest electron emitted is approximately. You see that equation has to be used. That is your your work function is 4.2 eV. So you subtract 6.2, 4.2 from 6.2. So you get 2 eV. So 2 eV is the energy of the ejected photoelectron. So 2 eV means 2 into 1.6 into 10 to the power minus 19. eV is this much joule. So that is the energy. So that energy is you get as 3.2 into 10 to the power minus 19. So they approximate and write as 3 into 10 to the power minus 19 joule. We got 3.2 into 10 to the minus 19 joule. So that is to be checked because sometimes in the multiple choice exact answers will not be there. Nearly equal to the two answers you have to write. Then you come to the next one, that is the work function of the substance is 4 eV. The longest wavelength of light that can cause photoelectrons emission from this substance is approximately they are calculated. You see, you have to use work function is nu 0. So minimum frequency is nu 0. So at that time, you can also write this expression hc by lambda 0. So that lambda 0 is the maximum wavelength. This is the minimum wavelength. A minimum frequency. Minimum frequency controls the work function. So maximum wavelength will be, you calculate by using the formula W0 is equal to hc by lambda 0. You put the values and you get 310 nanometer. So in that answers, 4 answers are there. C is 310 nanometer. Then there is a graph. There is a graph for this one. So 38D. 38D is correct. You get this graph. There are 4 graphs. You have to choose the correct one. here, Einstein's photoelectric equation is your h mu 0 plus for half mv square and v square, you can write 80. So, if you write v0, it's by e plus by e. So, this we make a graph here. So that you can have and v0 in volt. So this equation is like ms plus the same is what should apply. Here is the intercept. Intercept mathematics, that is straight line. If it is positive C, then it will start graph will straight line graph will start from here. But if it is negative C, start. So this is a minus. This is a minus of and this point is mu. Because when mu is equal to mu 0, v0 is on this x-axis, because y code, yeah, correct graph. There are four graphs. So for it will be this one, D. The correct one is D. Then 39A. The work on the surface of a photoelectric photosensitive material is 6.2 eV. The wavelength of incident radiation for which the stopping potential is 5V incident radiation for which the stopping potential is 5 volt, lies in ultraviolet region, visible region, infrared region, and X-ray region. So this has to be calculated because you see what is the incident energy? Incident energy of the photon here will be the sum of this incident energy is equal to sum of these two. So this is work function and this is the E function. That is the stopping potential. So it will be H mu electron 6.2 electron volt, and this is your 5 volt is 5. So it is 5. And this 11.2 EV, how much? Good. X. This has to be calculated, and it is 110.7. Nanometer. That is in the ultra region. So the incident light must be ultraviolet region. In the ultraviolet region. The next question is the number of photoelectrons emitted for light of frequency nu higher than the threshold frequency nu 0 is proportional to threshold frequency, intensity of light, frequency of light, nu minus nu 0. It is very obvious. Then number of photoelectrons is decided by intensity of light. The answer B is correct. Then we come to the next one. When a monochromatic radiation of intensity I falls on a metal surface, the number of photoelectrons and their maximum kinetic energy are N and T respectively. If the intensity of light and radiation is 2I, that means doubled. The emitted electrons will be doubled and their maximum kinetic energy will not change respectively. So here you see only the confusion there he is making. The question setter is about the symbols. The maximum kinetic energy is called N, and number of photoelectrons is called N, and maximum kinetic energy is called T. So kinetic energy is decided by the frequency. So if the intensity is doubled, frequency is not going to change. So therefore T will remain same. Only the kinetic, only the intensity is doubled, so N is doubled. So answer will be 2N and T. There are making confusions, 2N to T, N and T, N and 2T. So you have to be clear that intensity decides the number of photoelectrons. So therefore 2N, and intensity doubled, so N becomes 2N. But the maximum velocity or kinetic energy is controlled by the frequency, which remains constant, that is T. So 2N and T, that is for A. Answer A is correct. Then the next question is 0.66. A 0.66 milligram ball is moving with a speed of 100 meters per second. The associated wavelength will be H. They say that 6.6 into 10 to the minus 34. You have to take joule second. That will be easier to calculate. So the mass of the body is divided by P. So it says that you find the value of lambda. So the H they say that it is taken as 6 into 10 to the minus 34, and P is MV. So N is 0.66 milligrams. This 0.66 milligrams. So milli becomes gram by writing this way. then gram becomes kg by writing this one. So we convert to ampere system. Then the speed is 100 meter per second. So this means here we say 6.3. And if you give 10 from this to this one, it will come to 6.6. Then turn to the minus 6, another 10. Then the minus 5. Yeah. So the wavelength associated with bismuth of mass is your 1 into 10 to the minus 29. Actually, but in the choice, there is no such thing. So you have to write B. Say you will write B as minus 29. So let us stop here today, and we will continue in September, 20th September, the same topic, that is dual nature of light. And, thank you for the sessions.
And dear friends, we are going to close this second session, but I am to intimate you that we'll be giving you these questions towards the end of this training program, and you will give it to the students. So you please note, and Sir will be taking, Dr. Mishra will be taking classes later on also in few other days. So you be ready. If you have got any type of doubts, you please be ready to ask Dr. Mishra on that particular day. Now, thank you very much for spending these hours with us. And tomorrow we are having chemistry. So you know your program that after each 7 or 8 days, we'll be repeating second program, third program, and fourth program. Thank you very much. Okay.